Hey, good morning, everyone. We are extremely sorry that December event is postponed to January for different reasons, and which is kind of natural in a meetup's lifespan. So the way we start, right? We start introducing ourselves to each other so that I saw there are 85 first timers for this event. So while you introduce yourself, you just mentioned you are a first timer or not. Okay. And then your name, where you work, why you are here. The three statements you just introduce. I am introducing myself now. I'm Debanshu Sahab. Uh, I'm in the industry from the age of the dinosaur, unfortunately. Uh, so I host this meetup since 2012. Some of my partners of that scene when we started this LSP meetup are here as well. Sai, Srini, a bunch of other folks will also come. So we'll start from this side. I think Hemant is sitting. So go ahead, Hemant.
Hi everyone, my name is Hemant Ramparia. I work as a principal.
The mic, take it closer to the.
Okay. Is it okay now? Yeah. Hi all, my name is Hemant Ramparia. I work at Oracle as principal cloud operation engineer. I'm here to learn new things about AI and all the stuff. Thank you everyone.
So just don't move the mouth speaker from your mouth when you are speaking. Yeah.
Yeah. So myself, Vignesh. So I work in JP Morgan as a software engineer. So I came here to learn from the senior experiences, like how the industry will be like, and also few engineering things. That's it.
Are you a first timer?
Yeah, I'm first timer.
Great. Thanks. Nice.
Hi, hello. My name is Subhash Veri, and I'm a first timer. I'm working for the startup as a DevOps engineer, and very happy to be here. Thank you.
Great. Thank you.
Hey everyone, I'm Ayush. I work at Falabella as a senior engineer. I think this is my 17th or 18th session.
Oh, man.
Hi, this is Razvi. I work at Razorpay. This is also my first time at LSP event, and I'm here to see the talks.
Great, and we'll be getting you next time in a different place. Obviously, that's the expectation.
Definitely,
Great.
yes.
Thank you.
Hi everyone, I'm Sejal. I work as lead DevOps engineer at Razorpay. I'm here for my talk to share what we have learned so far in our time at Razorpay and to get back the learnings from what is happening industry-wide as well. Thanks.
Great. Thank you.
Hey everyone, I'm Nehal and I'm a lead DevOps too. So this is my first time and I'm here to learn and talk as well. So yeah. So I work at Razorpay, by the way, yes.
Super. All Razorpay ones would be first timer, maybe few deviations. Okay, great. Thank you.
Hey all, Arjun here. I work as a senior cloud architect at Accenture. So want to learn about AI and
in front of you.
yeah. So I want to gain knowledge on AI and quantum. We have a session on quantum today, right?
Yeah, there's a session on quantum. Unfortunately, I'm going to speak about it. The slide is not yet complete, so I will add few more.
Yes, I want
Sure.
to learn about that. Yeah.
Great. Thank you.
This is Manohar, founder of a fintech company called Money Process. I'm coming for the last 10 years.
Yeah, great. So the problem is this, I'm facing light, the camera effect. So if I snap the photo of you, I see you blind. So that's what I'm seeing. You can't see your face. Great. Go ahead.
Hello everyone, I'm Chaitra. I'm from Jain University. I'm doing a third year BTech student. I'm first time here. I'm here to learn about quantum thing. So I'm excited for that. Happy to be here.
Interesting. There are listeners for quantum. Interesting. Okay, and this is a trend that we are seeing for last 4 LSP. We are seeing graduate students, undergraduate students joining in. Great. Thank you.
I'm Akash. I'm also a third year from Jain. I'm here to learn about quantum and other things.
Quantum interest is there.
Yeah.
Okay, interesting. Thanks. Thanks for coming.
Hello everyone. I'm Shruti. First time here. I'm working as an engineer at Cisco. So here to learn from the talks.
Great. Thanks. Cisco.
Hey, hi everyone. My name is Manish. I'm basically an ID consultant, do consulting for some of my European customer, and I am into. I've spent a lot of my time with OS operating system, and looking forward to these talks because the talk were really all techie talks with no product promotion, and that's something which I really look forward to it.
No, we don't do any marketing. Great.
Hi
Great.
everyone, I am Vinod. I am working at Krishnamurthy Software Solutions. I am here to understand the new things.
You are a first timer?
Yes.
Super. Great. Thank you.
Good morning, everyone. Myself, Amresh. I'm working with NMC Healthcare as a senior developer. First time here. Okay, along with me, I brought my cousin also.
Super.
Yeah.
Come, and we do quarterly without any missing event. So do join us all the
Yeah,
time.
sure.
Thank
Thanks.
you.
Hello everyone, this is Amit here. I work with Optium and I'm here to learn how can I keep my production stable. Thank you.
Super. That's the first talk.
Hi, I'm Amar Prusti. I'm an independent freelance IT infrastructure consultant. And along with it, I'm also into wellness and cycling. So anybody wants to discuss anything on wellness, cycling, I'm the guy.
During the lunch, catch hold of him. Thank you.
Hey, hi guys. So I'm Akash. I'm from Salesforce working as a software engineer. Actually, I am looking for this observability and Linux tools in this session that I thought that would be interesting. Yeah, then this is my first time as well.
Super. Thank you. Rizvi, you have listeners for you.
Hi, it's me, Siprakash. I work in SAP Labs as a senior DevOps engineer. I'm attending this since COVID time.
Super. You are a first timer?
No, I'm attending this from COVID time. This
Since
la-
COVID time,
largest-
then when we were remote. Great. Thank you. Back, behind. Introduce.
I'm Debarun Saha. I'm from NITK. I'm a first year BTech student and I'm here with my dad.
That's why he was missing to introduce.
Hello, everyone. This is Gaurav, DevOps engineer, currently exploring in the robotics domain and observability. That's
Super. Thank
not
you.
a first timer.
Yeah, I got it. You are first timer.
Hi, everyone. This is Harish here. I work as program manager in HCL Tech. I'm an observability architect, recently turned into AI platforms. So I'm here to, not for the first time, I've attended a lot.
You will see spare tons of information in the keynote itself.
Hope so.
Great. Nice having you.
Hello everyone, my name is Rakesh Roshan and I work as a DevOps engineer at OpenText. So this is my second event with this community and I am here to explore, learn and network with most of you. Thank you.
I never knew OpenText as a DevOps group. Great. Thank you.
Hi everyone, my name is Aditya. I work in IBM. I currently work as a pre and post silicon validation engineer. So you might not have heard of it much, but yeah, it's more on the electronics or embedded software side. I am here for the first time and yeah, curious to know about these things.
Super. Thank you.
Hello everyone. I'm Anirban Basu. I work in a startup Apexon. I'm a site reliability engineer working with Apple Pay. So I'm all into observability, monitoring and alerting.
This is the second time you are in
This
here.
is the second time. Last time visited in Google Kyoto, SRE Meetup. Yeah.
Super. Thank you, Anirban. You introduced? I did. Okay. Oh.
Hi, good morning and happy new year. I'm Orkudip Boshu, principal architect in Fidelity Investment, here to learn, and I also have a talk at the last.
Yeah, Orkodip saved me for the last talk. Otherwise,
Hi, good morning to all. I am Malik Ojna from MSN. I am a developer, so first time I'm attending this event.
Thank you.
Yeah, thank you.
I hope we will not desert in you.
Hi, this is Sampath Kumar, working in FIS Global. This is the fifth or sixth time I'm attending this. So I'm working as a DevOps engineer.
Thank you.
Hi, I'm Srinivas here. I work in Myntra as an architect for cloud infra systems, anything related to that one.
All the general, whatever is there.
Everything.
Everything of cleanup.
Yes.
Great. Sine is a veteran. We started together at Yahoo of this event.
Hello
Yeah.
everyone, my name is Ashish and I'm a front-end developer and I'm here to attend the talks.
Great.
I'm not a first timer.
You are not?
I'm not a first timer.
No, I know. You are known face. Yeah, great.
Hey guys, this is Dinil. I work for Samsung as a SRE lead. Been in the IT industry for about 20 years. pretty much into the IT infrastructure, security, SRE, DevOps, cost optimization. Devanshu was my manager earlier in Samsung.
He
Yeah.
just mentioned manager, bad or good, he hasn't clarified. So that's okay. Great. Thanks, Daniel.
Hello, I'm an artificial intelligence specialist over here. I'm working as a software engineer at Myntra right now, and this is my first time over here. So keen to understand about quantums, and let's see how it goes. Thank you.
Okay, so majority in quantum, less in observability today. I don't know. There's a pressure building on me.
Hello, everyone. First of all, Happy New Year. And thanks for choosing such an amazing place for this event. So I am Govind Soni and I work as a data scientist at Lam Research. And here came for, first of all, an amazing group of people who actively keep working on new technologies and new stuff. So I am here to just learn from them what's going new in the market. Thank
Now,
you.
I got a person, wherever I fail to answer a math question, I will pass it on him. Great.
Thank you.
Hey all, this is Harish. I work as a backend engineer in Seller App. I basically work on automating Amazon and Walmart ads. So this is my second time here.
Second time. Okay, great. Give Sai.
Hi, my name is Sai. I work for Skyflow, and I basically don multiple roles these days. So I'm an infra architect, pre-sales, post-sales, solutioning. Name anything that you need to do for a startup. I'm generally doing that. Yeah.
Super. Thanks, Sai.
Hi everyone, this is Anil. I work for IBM as a software developer, and I have attended this session I think quite some time back before COVID. So I've resumed it now. Yeah, I've seen you, so that's all.
Thanks for resuming.
Hey, hi everyone. Good morning. Myself Gangi. I'm working at Cisco as a AFS engineer. So the keyword brought me here is the large scale engineering. Scale is the keyword for me. Yeah, thanks.
Super. Great.
Yeah, hello everyone. I'm Gaurav. I'm working in AMD for their Pensando DPUs, and I'm here mostly for BPF to learn and see what people are doing in BPF.
Super. Thank you.
Hello everyone, my name is Pintu Kumar Prajapat and I am currently working at Bharat Electronics as trainee engineer. It's my first time to gain some new experiences, all that.
Super. Thank you. Anyone left who came later, didn't introduce yourself? You can get the mic.
Hi everyone. I work as a platform engineer at Paytm, and I've been in this community for like a couple of times, and I'm here to learn and meet new people. Yeah.
And you want to see how they serve the food, your competitors serve it, and compare. Great. Thank you.
Yeah, thanks.
Anyone left?
Hey everyone, myself Rakesh. I'm also community member since long. I think most of the familiar faces are here. No need to introduce much. But I'm pretty much passionate about learning and implementing AI use cases. Thank you.
Super. So do network during the lunch break. We will start now. Kick off with Vivek's keynote. Vivek is a senior vice president engineering in Razorpay. So Vivek will let us know how Razorpay deals with obviously the SRE space in a fintech, which is every time I think last 20 transactions which I did, everything came Razorpay. I was thinking, where are others? So how they managed to do it? So Vivek will still do something. We are 40 odd folks on a Saturday. It's not a very less feat. So it's great. Hope you all enjoy the talks.
I don't know if guys are able to hear this properly. Hello. I think this is better, right? Okay. Thanks, Devanshu. It's great to see all of you folks over here. What I'm going to talk about is not the fun part. I leave the fun part for the later. But I'll spend next 15 minutes talking about Razorpay and very small deep sides into a couple of things, right? What we have done well, right, over the last 10 years. So I'll quickly get started. So yeah, my name is Vivek. I have been with Razorpay for close to 8.5 years now. Built the entire payments engineering from grounds up. 8.5 years before it was pretty small. Very small company.
So my journey before I go, so 2007, I graduated. I joined IBM Software Labs. I worked on the AIX operating system, which used to run on their servers. That was the core OS things where I worked for 3.5 years, close to. 2010 was the time when India started seeing startups. Flipkart was the first startup which came in 2010. I joined a startup called Arcot Systems, again in the fintech space. If you use your credit card, debit cards, and you get an OTP verification, that entire authentication system was built by them. So they were ahead of their time. Had 70% India market for processing credit card and debit card transactions on an ACS server. So I spent 4 years close to working on high-scale systems, on-prem infrastructure, and the risk part of the assessment as well for them. 14, I moved to Flipkart, spent 1.5 years at Flipkart, helped build products on the customer support side. So Flipkart had a lot of customer support, and they need a lot of products to be built to handle customer queries properly. So very, very different interaction from the other things, because here you used to talk to the customer, understand what are their concerns. People are very finicky about orders getting late, payments not getting refunded and everything. 16, I moved to Ola. Again, spent majority of my time in Ola Money. The scale was huge. Within a second, we had to process the entire payments across 15 microseconds. And if it goes beyond a second, then the money doesn't get debited from the Ola, and that's a loss to the Ola, right? So that kind of systems worked on. 17 is when I moved to Razorpay, 8.5 years at Razorpay now. Okay. So me and Devanshu were speaking ki LSP pay, right? And this is what I got to know about LSP. I'm myself a first timer here. Great to be here. So LSP was founded in 2012, and in the last 12-13 years, what LSP has been operated on, it's a strong community of 42 plus 100 engineers, 3,500 plus participants have come through. And the entire rationale of being here is to network, understand what the different companies have been doing, not to reinvent the wheel, but to learn from other people's mistakes and scars. And that's we all are here to do. And the evolution of LSP also has been pretty amazing, right? While the slides are actually self-explanatory, I wanted to talk about this core value, right? What I looked at in the last years, not a single quarterly event has been missed. So that's 100% consistency, which is pretty awesome. It's not easy to draw people on a weekend, come and here, right? And kudos to all of you folks as well, right, who has made it here. So I'll go back to Razorpay, and people might know about Razorpay, but I'll give a little brief snippet about what Razorpay is, what we actually do. A lot of people understands only one part of Razorpay. I'll talk about the scale of Razorpay as well. So the mission, right? What is the mission of Razorpay? We want to be the one-stop platform of all money movement needs of businesses. One-stop platform. That's the difference between infrastructure and application, right? We want to be the infrastructure behind money movement. Okay. So if I have to talk about the evolution of Razorpay, right, across the years, 2014 is when we started with a core payment gateway stack, which is what you guys see. The checkout comes and then the payment happens, right? That's the core PG layer. But then over the last 10 years, we have multiple other products as well. So 2016, we released payment links, reporting, analytics. 2018 is when we released 2.0 set of products, our core PG layer, which is payment pages, current accounts, subscriptions, smart collect. 20, we launched corporate credit cards, route, payroll, and a lot of our capital business. 2020 is we invested in our omni-channel presence by introducing POS business. You would see a lot of POS devices of Razorpay these days. We invested in loyalty marketing stack. 2014, we actually went into marketing and loyalty, deep into marketing and loyalty stack, where we acquired companies, BillMe, we acquired companies, Boschwein, and we expanded to international as well. And last year, there is not on the slide, but last year we did a strategic investment in the consumer space as well. we actually made investment in POS to expand our consumer base as well. So this has been the journey for Razorpay. Sorry. So if you look at right, steadily we have built the products to power all money movement in the ecosystem to become the one-stop platform. So this is the slide we use actually do use for our all board meetings as well. So if you look the right-hand side, so typically what a merchant does, we'll take a typical merchant like Myntra. I heard somebody is from Myntra, right? So Myntra is pretty big, but let's assume Myntra is small. So what does Myntra does? Myntra has to collect payments, and if it is an omni-channel, it can actually collect payments from payment gateway, POS, payment links, subscriptions. So there are different ways of collecting payments. And that's where the receivable parts comes into the picture. Once the merchant has the money in their account, what do they do with that money, right? They have to do expense management. They do have to do vendor payments, bill payments, current accounts, payouts. That's how the merchants now spends the money. So that is the payable parts of the money. The third business what we have is the lending and treasury. So if a business needs money, right, and they needs money for a day-to-day business, we actually give loans also to our merchant. We actually issue corporate credit cards also to the merchant, right? So this helps them to in their growth journey. The fourth aspect of our product is marketing and loyalty. So if you look at the different kinds of products on the receivable and payables, you guys would assume we are a lot of data-rich components, right? We have data like every consumer, right? 35% of the India consumer is transacting via Razorpay. So that's the rich set of data what we have. Leveraging that data, we have our loyalty and rewards platform, where a merchant can come and use this platform to reduce their acquisition and retention costs drastically. And that's a huge investment we have made in the last 2 years. So, yeah, 2014 first business. If you look 2024, this is like, I think an year last year, it's 5 million plus businesses what he has onboarded on our platform. So there are 5 million plus merchant transacting on Razorpay's platform. The TPV is the total payments volume. Definitely started with 0, and we are doing $150 billion in a year. So that's the scale we have gone through, right, in the last 10 years. I don't know which is the last company in India which has gone through this kind of scale in the short span of time. So I think this gives the scale, and a lot of the products also, what I show, a lot of this scale, what you are seeing, right, it was not built in a day, in a year. There was a constant investment across multiple years. And the platform mindset of building products, scaling products, keeping 3 years, 5 years in mind has helped us to evolve and execute much, much faster in this space. So for any businesses to succeed, right, it is very important, I believe, to have the few first principles very sorted out. So the 6 operating principles we take very, very seriously at Razorpay, right? And we ensure that we invest mostly on these is security, compliance, reliability, availability, scalability, and innovation. So if I talk about security, I don't think security, anybody will disagree with this point on security, why security is important. But due to the time, I will just cover 2 pointers in each of these operating principles, which I believe is the most important, and people don't invest a lot in these, right? Assuming that these are lagging indicators, we can do it next year, 6 months later, but these are very, very important. So there's a continuous bug bounty program which Razorpay runs from very, very starting, including external folks, to ensure that external parties, external people can come, exploit our system and find bugs before a malicious party actually does it. This helps us always be ahead in the race. A lot of banks and everybody have actually been through this, and they have done it retrospectively, not proactively. Automated patching, I think a lot of DevOps folks are here, they would understand this pain. So your application infrastructure requires regular updates. And this is very, very important. And this is the tax we all have to pay. I don't think if you ask for a product or a business folks, what is the outcome? There is no outcome of this, right? It's a tax we have to pay for our systems to be up and running fine. Compliance is much more critical for fintech space. We are heavily regulated. Close to 30 to 40% of our bandwidth actually goes at times just being ahead of compliance, not with compliance, but ahead of compliance. And we invest a lot in terms of making people aware of what compliance is. So it's so routine that I don't have to get myself into any of the compliance asks which comes to the team. The team is able to handle it on its own. And this has been a journey for us because we ensure that every person who is building products, who is writing code is also aware of what compliance Razorpay has to go through. And the developers are smart enough to ensure that they bake it into their day-to-day coding guidelines. So everything what we build is compliance aware. And while strong internal regulatory framework, we have a lot of audits anyhow happening regular through the year being a fintech, but even companies who have to just, those are not fintech, not PCI DSS, have to just go through SOC 2 compliance and as well. There needs to be some activities happening on a regular basis to understand that we are ahead of the compliance. Third for us is reliability. Right? Reliability means very different things for different businesses. For us, reliability is about ensuring a payment is successful for the customer if I said it is successful. So once I say a payment is successful, I can't go back. So that is reliability for me. And sorry. And why is it challenging for us? Because we do close to 15 million transactions in a day, right? And there are a lot of distributed systems through which the payment and status of different things goes around. It's very easy for some of the statuses not getting updated on time. But if you look at reconciliation also, right? The money movement for a payment happens across, there's a merchant called Myntra, there is a Razorpay, then there is a gateway, then there is a Visa MasterCard, and then there is an issuer bank from which the money needs to move. And then there are credit card systems as well. So there are close to 6-7 systems through which the money needs to move when one payment happens. And trust me, most of the systems are still file-based across, even Visa MasterCard systems are file-based. So the entire money movement across millions and millions of transactions needs to happen every day during the night. So it is very important for Razorpay to reconcile this transaction across all of these systems and ensure my merchant gets the money the next day. So that helps build a lot of trust with our customers. So reconciliation is very important for us. And for us, payment status and reconciliation are the reliability factors, top 2 reliability factors. Availability, I think everybody understands, right? A great system is of no use if it is not available. And for us, a lot of merchants' business, day-to-day business depends on our system. If Razorpay goes down, their business comes to halt. It goes zero, as simple as that, right? So it is very important for us to be 100% available. But yeah, it's a software. Issues will happen, outages will happen. So we invest a lot of time in our MTTD and MTTR, detection and resolution time, to ensure that it's top-notch, right? And a lot of investment goes into reducing this MTTD and MTTR. Scale, I think the scale here is definitely, so I think when a company is small for the first 5-7 years, nobody thinks about cost. But as you grow, right, the cost also increases linearly and at times exponentially. And you can't take it. For the business to sustain, you just can't take it. So last 4 years, we have spent a lot of our energy in understanding, partnering with AWS in terms of how to reduce cost. So we need to educate our developers not to just write code. They need to write cost-performant code. And we'll talk about what a cost-performant code as well means. But they need to write a cost-performant code, and it starts from the lines of code you write in itself, right? What kind of infrastructure you use, how well you understand the infrastructure on which you are going to deploy, what are the right set of technology choices, so as simple as, right, if a developer doesn't understand the instance size, what does it mean? He is never going to use the right size of instance, whether it be the EC2 instance or Elastic Cache or anything. So scalability is very important. We have reduced close to 80% of our AWS cost in the last 3 years per transaction. The sixth is the innovation, right? And there, that is where the product build sits actually, right? So innovation generally, I divide into two parts: incremental and strategic. Incremental is your, let's say, next 6 months to 1 year. Strategic is the next 2 to 4 years. And I believe both these investments needs to be happen very, very separately. You can't have a team doing both incremental and strategic innovation at the same time together. It's never going to happen. So while as a company, we have a lot of next 6 months, 1 year win, there are a lot of dedicated focus to have next 2 to 4 years win as well. We invest a lot in those kinds of products, those kind of architectures who is going to give us win in the next 2 to 4 years. So I think I'll touch a little bit on availability. So yes, please.
So, am I audible?
Yep.
Okay. So you mentioned that Visa, MasterCard are still on the file-based
Yes.
system. So, I mean, what else is there? I don't know. Can you?
Sorry, come again?
I mean, what else is the alternative? I mean, if it's not file-based, how else?
All right. So UPI handles real-time reconciliation. It's a real-time reconciliation, UPI systems.
Okay.
It's not a one day, millions of transactions upload in a file, then put into an SFTP, not that.
Okay.
They do real-time settlements.
Okay.
UPI.
Thanks.
Okay. So with the availability, so I think Razorpay has a very good brand name and a brand story, right? And while it's a good thing, it actually encourages a lot of malicious users and exploiters come test our platform, try to take us down, right? So obviously there's a lot of DDoS attacks keeps on happening on our system, and for the systems to have a high uptime and availability, how do we mitigate that, right? So again, all of this, what I spoke about has been a learning. Even the state, what I'm talking about, it has taken us 2 to 3 years to reach this stage, and we are still continuously investing in this as well. So definitely a top-notch DDoS detection system, and it cannot be a single system which helps to do this. It has to be a combination of multiple systems, leveraging a lot of AWS plus in-house built systems, which I'm going to talk about as well. So a lot of investment in those DDoS, active DDoS production systems, and then technology which enhances the capability of these systems to detect faster. If I have a manual intervention in between, it's not going to happen. By that time, my system will be down. How do I make my data so smart that automatically I'm able to detect these users and block these users as well? Right. So with a lot of these investments and continuous investments, we were able to stop close to 542 P0, P1 DDoS attacks last year in itself. Right. And definitely with IPO inbound and a lot of news flowing around, this has increased drastically in the last 3 months. And till now, we have been able to thwart each and every one. So that's the scale. So what our strategy has been. So definitely, right, we have partnered with AWS a lot, and any of the cloud providers, what you guys work on. Very, very deep partnership in terms of understanding, getting their solutions engineers sit at our office, understanding each and every component of how it works, how different companies are doing it. Because there are a lot of companies, much, much larger scale than us, definitely. But how they are doing it, right? How is AWS doing it? Understanding that, leveraging WAF and Shield are definitely those are the two products what they have pretty well. But they can't stop it, right? And I'll tell you also why they can't stop each and everything. We have invested, we have built our own API gateway as well, where we have a very, very granular throttling, as granular as close to a per second throttling. You can't do that on Shield or WAF, right? And a lot of these DDoS attacks happens on the API context. So if you understand how Razorpay works, it's a checkout. Checkout hits our backend systems, and those checkout has public keys. So now any of the malicious user can come, take out this public key and start hitting those, right? There's no other mechanism of doing it. It will come to an API gateway where I will say ki it is authorized, not authorized, and then take it down. So AWS components cannot do it. And that's why a lot of contexts are there, which we have built on our API gateway, how to do that. Near real-time rules, as I spoke in investment in AI ML to ensure that we are able to do a lot of these stuff automatically without manual intervention, because if manual intervention is there, the systems are already down. By the time we react, it's down. So while we say that the microservices architecture, what we have, we call the muscle of the power processing, the power of the payment processing. API gateway is our brains, and we love to call it edge. So this edge is very, very in-house built. It performs authentication, authorization for the entire suite of products what I showed there. So this is the first layer through all of the public requests goes through. It is highly scalable. I think it's request per minute, not it's request per second. It's highly scalable, fill millions of requests per second. I can rate limit at a very, very granular levels at a per second basis. It also gives me an ability to, based on the pattern, I can predict whether I need to do a secondary authentication captcha or just block it or allow it. And it is ML enabled for real-time updation on blocking rules on WAF as well and on edge as well. So this is a very, very simple diagram. I think this is what best I can do in the next 2 minutes. And that's why it's a very, very simple diagram. So if you look at this is our ALB layer where the WAF and the shield is also incorporated. Edge is our entire system, which does the authentication, rate limiter, insights. It does a lot of other things as well, but I put this. And then any request passes this and goes to Razorpay component, which is another 200 plus microservices over there. Right? There's a continuous feed of data from edge to data lake. And then there's a continuous ML model running, right, which looks in the data lake and creates the alerts on either edge for the rate limiting or on the WAF. So WAF is generally your pattern based, while edge could be merchant ID, route specific, merchant ID plus route specific plus parameter specific in that particular route. And then I can put a blanket rule over a route across all MIDs. So I can do as granular as much as I want on my edge. But again, edge is also a system which will go down at some point of time. So it is important to stop most of the alerts at WAF layer itself. And whatever WAF cannot do, those only should get passed here, and we are able to handle it here. So this is the entire architecture what we have built in the last 3 years to stop, and we are continuously investing in it to actually help stop all the DDoS attacks on our system. I don't know if time permits. You can go ahead. Okay, I'll just quickly try to wrap it up. So innovation I think I spoke about cost, and you guys, most of the companies who are actually looking for profitability or actually have scale will be having a goal around it for sure. So I think while our TPV grew by 70%, we were able to reduce the cost by 60%. Now we have done by 80% actually. And again, very, very deep partnership with AWS or any of the cloud providers we are working with, understanding how do they work, what are the best services to use, move to managed services mostly, actually then hosting services in-house, and automate. So I think we moved to Aurora databases from our typical RDS, MySQL or Postgres. Number of replicas goes down. If you use it right, it actually reduces cost. So earlier we were living with a fallacy that Aurora is expensive. While the charges might be expensive, you are able to do much more with much less of Aurora than what you are using for RDS. Earlier we used to have 5 replicas. Now we are doing with just 1 replica of it. And it is working very well fine. It has reduced costs drastically for all of us. Spot, all of our all of our async workload and non-P0 workloads run on Spot. Again, Spot there are a lot of, it's not like you just move to Spot and works, right? You need to deeply understand how Spot works, how to make a system more resilient when it works on Spot, right? Spot can go down in 2 minutes time frame. How do you make your systems much more resilient around it? And the third is Graviton, right? As more and more Graviton versions are coming up, I think they launched a recent 4 or 5 series, I think, for Graviton, which again is, they're saying 25-40% cheaper than the previous. So moving to these instance size also reduce the cost drastically by 15 to 20% for us. And EC2 Aurora is what constitute your 90% of the entire AWS cost. So again, these are all 2-3 years projects, right? While I'm able to describe in 2 minutes, the work is humongous, which goes around all of these to make these things happen. So quickly wrapping up, what's next for Razorpay? I think global expansion is definitely there. I think we have launched in Malaysia a couple of years back. Last year we launched in Singapore. This year we did a soft launch in US. Hopefully we launch a couple of more countries in the coming year. So definitely that's on the cards. Next gen architecture, I think with AI coming in, I think it's definitely a work needs to be done, how your code structure needs to be written for AI to read it properly. How do you let AI understand your connections across multiple microservices, how AI can actually go and write code across multiple services given a plan around it. As well as with the team size increasing, we also face a challenge around productivity. There are a lot of developers writing code on a single repo. How do you structure your code so that they can write code without impacting the other parts of the code? So those are the lines what we are thinking. Scale is not primary here for this next gen architecture. For us, it is AI and dev productivity, which is scale we are already able to handle. So this is what is going to be our next gen architecture. The third is best in class experience. I think with the growth in the SME market, which is very, very non-tech business, it's very important to understand how they use our product, how they consume our products, and how they can live without even worrying about payments. They don't have to worry about payments. They don't have to worry about how systems will behave and will it be resilient enough. They don't have to understand, simple, blank. It's an infrastructure which is there for to work. Like AWS works for me, it needs to be infrastructure which works for them. So a lot of focus is going into making that experience very, very seamless. We have done a lot. We still have to do a lot. So we continue to pursue our mission to being a single stop payment processing platform for all our merchants. And it is still day one for us. We have a lot to do. We have a lot to win over. That's how it is. And yep, that's from me. Yeah. Yes, please.
First of all, thank you for your talk. Lot of learnings happened. Here. Okay. Wanted to say that you have mentioned about AWS that 80% cost have been reduced over the years. So I want to know that what you talked about reliability also. How much of your infrastructure is dependent on AWS, and in case of an outage, how do you handle that? You move the traffic to on-prem instances. How do you do that?
So Razvi is there. So if you're talking in terms of, so we are a single cloud dependent right now. So if your question is if the AWS goes down, do we go down? Yes, we go down. We are not a multi-cloud system right now.
Anything happened like that before any outage, or how do
So
you?
I don't think there has been any instance recently which has impacted us by AWS going down. There were a couple of outages on Cloudflare and AWS, but none of us impacted us. We have a DR which is WIP, right, from Mumbai region and Hyderabad region. So that is WIP. Anyhow, we have to do it as part of the compliance. But multi-cloud is something that we are not championing for right now. Reasons is one is definitely a lot of bandwidth. Over the years, we have tightly built our systems with AWS. So if you have to do a multi-cloud, a lot of bandwidth investment has to be done as well as cost investment, right? So we are okay. That's a conscious call we have done not to do that right now. Anyhow, we have a product called Optimizer, which a lot of our merchants use. So it's an aggregator. So what it does is that if Razorpay is down, it will automatically route traffic to some other gateway to ensure that the merchant's business doesn't go down.
Thank you.
Hey, thanks Vivek for the quick insight of your product. I was just wondering that you talked about cost optimized code. That what is that code through which you optimize the cost and all? Can you give more throw more light onto it?
So I'll talk about what we did when we actually moved. So uh, everybody, right, after 4 years, you are sitting on a monolith. 400 developers are writing code on that monolith. It was an API. It was in PHP for the right reasons at that point of time, because front end, back end both can be done on the PHP. You don't need a backend microservices. So over the time, what happens if you don't have the right checks and balances? The code is very, very okay. The models are written wrong. The choices of technologies are wrong. PHP as a scalable language itself was wrong because it takes a database connection. It doesn't leave it till the entire request goes off, irrespective of how much time you have done the DB query. So the code was written in such a way, async codes were not there. There were no async processing. Everything was sync processing because at that time it could handle. So we never built the code in such a way that it can actually scale. And it used to hog a lot of resources because we used to keep on running. We used to keep on scaling, and keep on running it, right? If we would have thought about async architectures like we are thinking now, if we could have think about database, okay, at some point of time, 70% of our database storage was in just indexes. 70% was just indexes, right? So all of these things, right, have to be kept in mind. So we need to think in terms of next 3 saal mein, right? What is that we need? And we need to write our code also accordingly. And with the AI coming in, I'm very, very hopeful that if we are able to construct our code or segregate or organize our code in such a way that the AI is able to read it and it is able to join multiple pieces of code together, then given a plan, it should be able to write my entire code across multiple services and say, "Bhai, this is working now." Right? So the next set of architectures, what my teams are trying to do, we are keeping this in mind. It has to be done with an AI first, right? My AI should be able to read the code.
Okay, my question is more on how you are handling multiple countries, right? So because you are deploying into different countries, India scale is different versus the other countries, right? So how you are dealing that?
So that is why it was in the expansion. Maybe 2 years later, I will give you a talk on how we actually cracked it. I'll tell you how we are doing it. We are not doing bad, but we realize there's a lot of things we need to do it. And it will definitely take minimum 1 year for us to crack it. So what are the tenets, right? First tenet is that we are not to do multi-branching. There has to be a single branch that is finalized. I think we are not doing a multi-branch deployments. So single branch, master branch is what is going to go into all of the countries. The infrastructure needs to be definitely separate. I think Razvi's team is working on it, so he'll be able to give you a lot more inputs around it. But we are going into a cell architecture where what we are trying, we are going to templatize our entire infrastructure and say, this is India, and you can actually copy and emulate the entire thing for, let's say, Singapore. And it automatically deploys the entire infrastructure. The second stage, what we're looking is application deployment. Right? Similarly, when you have the templates for the pipeline, we'll have a templates for the applications as well. Geography-based code hoga, and it will get deployed there. And the third is then ensuring the smoke test of whether the infrastructure is working or not. This is very, very 30,000 feet, which I'm talking about. There's a lot of problems because of secrets are hard-coded in a lot of places, right? You can't have the same secrets for a different country. AWS zones are hard-coded in the code, right, to point to. So a lot of these things moves to a config-based system. So what we have done is that we are trying to move almost everything to a config-based systems where it can be, which will drive for different geographies separately and do it.
So it's going to be a SaaS kind of solution, multi-tenant based kind of is what you are doing, or?
So it can't be multi-tenant while it's still a multi-tenant for us. Like Malaysia is running on India stack because it can. But while the system will support multi-tenant, you can't have it because of the DBDA guidelines. Every country is going to have it at some point of time. So Singapore, we have a separate deployment.
Okay.
US, we have a separate deployment. Like India in itself, trust me, our different entities needs to have a separate deployment and now a different data lake as well because of regulations.
Got it. Thank you.
One thing I want, yeah, for sure. Yeah. So one thing I want to understand, when you say that all the different segmentation, all the different segments to be added together for the AI to understand it better. So I want to ask one thing, how much reliability and dependency you are expecting from Gen AI or the AI part in the future aspects? Or is it only for understanding the code base and trying to implement more use cases, or is it like more into the agentic AI or some other applications which can be used using the Gen AI or something?
Sure. So, if some of you would have, so there is a GFF which happens every year. It's organized by NPCI. It's a 3-day fintech festival which happens in Mumbai. We launched quite a lot of products partnering with Big Basket, NPCI around agentic payments, where you can actually authorize an agent to make payments on your behalf. No authentication pin required, anything via UPI. There's a feature called single block multiple debit, which UPI has released, which helps you do that. But if you ask me internally, how do we do it? So we look at AI into 3 parts. First part is internal productivity, where coding is just one part of it. But there's a lot of other things which can help you in debugging issues faster. Coding agents are definitely on the cards. So there are a lot of things which can be done. The second part is your executives, which is your ops agent. How are they leveraging this AI to solve customer issues? Nothing customer facing, but let's say a workflow engine or manually checking a merchant's website and saying whether it is mule merchant, fraud merchant, or not merchant. They spend a lot of time. How leveraging AI can we reduce that 30-minute cycle to a 2-minute cycle? So a lot of investment on those areas, right? To making our agents more efficient, doing the regular day-to-day grunt work. The third is the customer facing, where we actually leverage AI to directly interact with the customer, resolve their issues without opening a ticket. Or let's say I'm able to negotiate a pricing call. So we are making investment. So there are a lot of examples like that. We are making investment continuously in all of these 3 areas. I think last month, our marketing head was telling we were able to close, I think 2 or 5 pricing negotiation via AI. Merchant ke saath, the AI went on call and able to close 2 to 5 pricing conversations. So I think we are doing a lot of experimentation and POC and everything. There's, I think, minimum 1 hackathon every quarter at an org level, just on AI. So we have made progress in all of these. The developer part has been matured for the industry for sure, right? The customer facing part is not matured as people expected it to be, but it will come through. There is always a human in the loop, but that will also go away in some point of time they'll take. Right? So yes, Razorpay is investing a lot, right? I think you should read about GFF launches and look at some of the demos what we released also. It's pretty awesome. It's pretty awesome.
Thank you. Thank you.
Thanks, folks. I'll be around for some time. So please, we can chat around if you have any questions as well. Thanks a lot.
So we'll have opportunity to ask conversation. So we are a little bit delayed.
Thanks, Devanshu.
Doing a fintech in India is not a very easy thing. It's highly regulated, as it says, and they're doing a great job. Kudos to the entire.
Thanks a lot, Devanshu.
Thank you. Okay, I will now quickly invite Rizvi and Sajal here on stage with the next talk of the session. And this is once again from Razorpay, and they are the folks who manage stuff for us so that our payment doesn't fail. So get it there.
All right. Hi, everybody. Good morning. I am Sejal. Good morning. Happy New Year. I'm Sejal. I'm a lead DevOps engineer at Razorpay. And I also lead the observability charter from DevOps and at Razorpay. So, let's try to get comfortable with each other. I'll try to have you visualize a situation that most of us have been in. Now, imagine something breaks in production. Not catastrophically, not with alarms beaming everywhere, but just enough that you know something is wrong. And like all the good engineers have been trained to do, you pull out logs. And you see obviously that nothing is directly broken, nothing is obviously broken, but there are hints. There are certain hints that point to certain failures, there are certain inconsistencies, there are certain messages that might look important, but you're not able to find the complete story through that. So what do? I think at that point, every engineer involved in the incident starts to chase their own theory. And that time it stops become debugging, it becomes detective work. You start collecting evidences to support your theories, and the culprit might be sitting somewhere else. And like every bad detective story, there could be many, many clues. And in our case, many, many logs. Right. So similar incident happened at Razorpay. I'm giving you internal news, guys. Our internal Docker registry harbor, it suddenly became inaccessible. Application across the cluster started failing. Pods were not able to restart because they were not able to pull images. And the impact was widespread. And like every good engineer, we pulled out logs. We checked harbor logs, we checked authentication logs, we're checking ingress logs. Nothing is telling us the full story. So what do we do to stop bleeding? Can anybody answer? Restarted Harbor. Thank you. Great. So we restarted Harbor and magically things started working. Obviously, we felt that restart fixed something, right? So next day, like good engineers, we went on to an RCA call with calmer minds and fuller timeline. And when we did that, we saw this one line. So what had happened is our security team was testing a firewall rule and they had added that. At that time, Harbor went down due to it. And coincidentally, at the time when we restarted Harbor, they had removed that firewall rule. So that one line was able to explain us the entire incident. That one line buried deep under CloudTrail and WAF logs. But since we were logging everything, that signal got lost and our MTTI went up. So that day, guys, we learned a very, very hard lesson. Logging more does not mean understanding faster. Without intent and prioritization, logs don't just fail to help you, they actively slow you down, right? But I mean, what was the problem? Was that bad logging? No, it was normal logging, but it was normal logging at scale. And you know, that's the thing with logs. Logs do not scale with clarity. Logs scale with fear. Let me try and explain that. See, logs are just the easiest things to add, right? When you don't fully understand its system, when you do not fully, you do not fully rely on your production system, when a new feature is added, when a new failure mode is added, everything adds new logs. And during an incident and after an incident, we add even more. But you see, over time, all of this accumulates, and it's not the understanding that's getting bigger, it's uncertainty. Because after a point, you don't log so that you understand better, but you log because you're afraid to miss something. And that takes the logging into a very bad direction, right? The same thing happened at Razorpay. We reached a tipping point where logs were not just noisy, they were slow, expensive, and risky. And when we say expensive, obviously cost is always a huge driving factor for us. But it's not just the storage cost. It's the retention cost. It's the incident time cost. It's the query cost. Because with the sheer log volume that we had, our queries were becoming very, very slow when we needed them the most during the time of incidents, right? Retention decisions started to become scary. Because what if we ended up deleting something that could leave us blind into a future incident? So we were stuck in a bad place. Keeping everything was unsustainable and deleting aggressively was unsafe. So what did we do? We realized something, folks, that this was not an engineering failure and this was definitely not a tooling problem. We were not treating our logs right. How do you treat logs right? You treat logs right by designing them, treating them as a production system, one that needs intent, one that needs design, and one that definitely needs engineering discipline. So what we did? We engineered a clear set of design principles for logging as a production system. And I want to take you through that. Number one, log intent matters more than log level. First thing we understood was log levels were lying to us. Info, error, debug, they don't tell you why a log exists. They only tell you how loud a log is. And we wanted to understand if a log is getting pushed into production, why? What is the need of it, right? But that's the thing. It can have so many reasons. You add a log because you want to capture a user transaction. You add a log because you want to debug an unusual workflow, right? But if we let intent explode that categories, we'd be just recreating the problem that we are trying to solve. So we forced to converge ourselves. And surprisingly, we came up with exactly 3 categories in which we could fit all of the service logs that we had. Number 1, critical tier. In critical tier, we were having those logs. If you miss them, you will essentially have failed or irregulated auditory compliance reviews. Basically, missing proof of business critical transactions, money movement. Then there was major tier. The major tier was highly supporting operational debugging, monthly reviews, monthly operational reviews, and SLA tracking. And third was minor tier. Minor tier basically had non-critical business application logs. It had debug logs. It has verbose application logs, basically everything else. And now this seems like a very small thing to do. It took a huge amount of time. It took a huge amount of bandwidth. And after that, a lot of questions that were feeling subjective before, they became very obvious. The scary retention decisions, they became obvious. The storage tiering, that became obvious. And the cost trade-offs, those also became obvious. And we realized something. Once you know why a log exists in your system, you can decide how much it is allowed to cost to your company. Next up, design principle 2, debug logs are not insurance. Acha, we have done our cleanup, and now we can clearly see where our most log volume is coming from, right? And it was not from critical tier, not from major tier, it was coming from minor tier. And debug logs was a huge chunk of it. Debug logs, the logs that we add purely as, insurance. So what did we do? First instinct, application team ko bolenge fix karne ke liye. They have added debug logs, right? No, wrong. Why? Because we are trying to treat logging as a production system. And once you want to treat something as production system, the central changes have to go centrally. Also, relying on application developers to do it slow, inconsistent, and it couples your log volume control with deploy cycles, which we did not want. So we moved the control plane to somewhere where logging could actually become a central production system. We have something called as fluent bit. That's a central component from which all of our logs flow through before reaching our storage to query systems. And we turned debug logs off at that level. Not rate limited, not sampled, off. But that was not the power move. The move was that we could enable it back on demand as and when we needed at any layer. We could enable it at application level. We could enable it globally. We could turn it back temporarily. We could turn it back off again. That was the move. Because we were able to remove a huge chunk of log volume that we were not actively using from our storage layer, but still making it usable when it is needed by application team. So debug logging became a runtime toggle and not a code change. Quickly moving to design principle 3. Sampling must preserve truth. Now, what should log offer you? What should any of your application log offer you? What is the expectation after an incident? It should tell you the entire story of what exactly happened. And it should not tell you just this happened these many times. This happened a lot of times, right? We are expecting that. And we wanted to ask ourselves that question. Is our logging system doing that? Is our application logs good enough to tell us a story of what happened during an incident after it happens? So we started from ground zero. we scanned our entire code base, we parsed all of our source files, and we created execution flow graphs and function call graphs. And then we located log statements in these graphs. Why this mattered? Because logs do not exist in isolation. They exist and make sense in this flow graphs, in this execution paths, right? Once we did this, we took out the highest frequency logs and we created a very clear evaluation chart for them. Every chart had log, the log line number, the log message, and its execution context. And for every log, we documented why it existed, what information was it providing, and did it preserve truth. We clearly saw a lot of redundant logs going away, a lot of verbose logs going away, a lot of logs that were replicating metric data going away, right? The rule was simple. If it did not preserve truth, it did not need to be there, right? And we also, when we had this set of action items, we could actually prioritize our action items on the basis of how much a log volume reduction an action item is doing, or of a log volume reduction, so that we can preserve the most truth while removing the most amount of logs. And this is the third design principle, which made our logs not just quieter, not just the log volume go down, but actually sharper, which made more sense to us. And now the most interesting part, folks. You can't optimize what you can't measure. So now imagine you're doing log optimization activity at your company as well. What is the metric that you would choose to measure how much optimization you have done so far? Surely in terms of log optimization. Any suggestion? Very quickly. Are you answering my question or are you asking a different question?
I'm just building up what he's saying. Like in a time series, if I plot the graph, like I'm seeing the pattern is recognizable, then we can understand that everything is going on.
Right. All right. So probably log volume, right? A single log volume or the entire log volume for the day. If you see reduction in the gigabytes of the log that you're pushing, that looks like a valid metric to judge log optimization, right? Whether you have...
No, I am not saying that. I am saying if you see a log, you have to, like, are you able to place it somewhere in a proper function call? So
Yes.
maybe that's the, I mean, you are asking what metric can you use? So I'm saying any log, it should always be traceable to a function call, and that function call should also be traceable to some other function call. So it's like no log should stay in isolation. That's what I meant. When you said, how do you measure whether we did our job well or not? So
That I believe that what you're speaking about makes more sense towards log hygiene, whether your log exists and does it exist for a reason. But if I ask you that, hey, can you reduce, so much cost for me when it comes to the logging cost? How do you measure that? So you measure that either in terms of logging cost, how much that costs you, or how much you're actually putting out log wherever you're putting in a third-party tool or your self-hosted tool.
then I would answer according to your intent thing, right? You had three intents created. One is the critical and major and the minor. So maybe that categorization, now that you already have bucketized those things, so now the metric could be that maybe more than 50% has to go in that critical bucket, and maybe 10-20% should be in the minor or something. So maybe that can be your metric. I mean,
Yeah, that definitely could be one of the metrics again of how do you categorize. All right. So in terms of optimizations, we are talking about the sheer volume reduction of logs, right? I mean, the categorization part is how you correct logs. So we're talking about log correctness here, and here we're talking about direct reduction. Obviously, that plays a very important part in doing the optimizations, right? All right. So going ahead, moving on from here. All right. So obviously, log optimizations sounds very synonymous to reducing your log volume that you're putting out, right? Reducing cost of logs. But that actually is not the right metric. Actually, it's a terrible metric because your high traffic applications will always emit more logs, and your low traffic applications will be able to log irresponsibly. So comparing raw gigabytes of these applications probably is, fundamentally unfair. So we wanted to find a metric that basically tells you how much logging are you doing relative to the work you are putting out per application, right? So a metric that tells you that how much you're logging per unit of work. Now, what is work? Work is anything that can produce logs. HTTP request, your Kafka consumers, your SQS messages, anything. So we started asking this question to application. This was our metric, cost per request, log cost per request, right? But now we have a metric to compare applications. This helps us draw comparisons across different kinds of applications that existed in Razorpay. And there are plethora of them, right? But now what is a good baseline? How do you even tell that whether this application is doing well or not? So what should be your baseline? We didn't want theoretical perfection. We wanted achievable best practice. And that is why we looked at our own data. We didn't look at industry data. We were looking at our own data. We created a ranking of applications on the basis of our own metric, cost per request. And then we took the P25 percentile as the baseline. The top 25% most efficiently performing applications log-wise. And that was our baseline. Now, if you come and ask me, hey, is my application, good logging hygiene wise or not? How do I tell you that? So there was a different calculation with it. There is a lot of mathematics here, guys. Please get ready. Get your engineering brains out. Yeah. So log cost ratio. So log cost ratio is basically your cost per request, your apps cost, your apps logging cost per 1,000 requests divided by your P25 baseline cost per 1,000 requests. This gives out a ratio. If this ratio is less than 1, well done, great job. If it's greater than 10, I mean, you will get highest reduction target. And this is how we were able to tell applications, you're not doing a good job or you're doing a great job. But yeah.
You took P25, 25 percentile on
P25, yeah, that's a very good question, actually. See, so there were 3 options. P50. P50 tells you that if you take this baseline and half of your applications are performing well, half of your applications are not performing well. That's a pretty linear one, if you ask me. P75 is not a good number because, most of your applications are not performing well. P25 seemed like a very stretchable but still achievable baseline. Top 25% applications. That is why we went with P25 as baseline. Right? Okay. Yeah. But now, obviously, as we have spoken about, different applications have different work, right? So even if you're normalizing them on the basis of request, there is still different kind of jobs that applications have to get done. So let's say if there is an application that is trying to handle a fraudulent transaction or is actually trying to do some business critical money movement, it would need more traceability. So how do you factor that in when you're comparing their log hygiene? So bring in transactional criticality. Transactional criticality is a score that we gave to each application from 1 to 5, 5 being the highest. And on the basis of that, we provided certain relaxations over their logging reduction targets. And that is also mentioned here. Criticality 1, no relaxation. Please go and fix your systems. Criticality 5, 40% relaxation. And this is how we believe we covered a lot of, hows and what's around how to optimize logging needs. All right. But again, something that you cannot visualize. You have given applications targets, but something that you cannot visualize, you cannot actively compete upon, you cannot actively talk upon. How do you get that into working with the engineers, right? And it was nowhere visible because logging bills are always suppressed in monthly reports and, month-end bills. It is always someone else's bill. Why should we worry about it, right? No, we made it engineers' problem. We made it BU heads' problem by showing that on their faces what they were doing. We created log-wise. So this is basically split-wise. Everybody aware of split-wise? We have all gone on trips. But this is split-wise, but for logs. Basically, we created a Grafana dashboard which showed you how you were doing in terms of the metric that we have given out for log hygiene. So it has cost in passive per transaction. It has average units consumed per million transactions. It had a lot of trends going on for you to see. And the most fun part, we had average daily cost per BU head. So these are our actual BU heads, and there was cost associated with it. And this was a dashboard very much visible on the basis of which people were being called out, people were being appreciated, and a sense of competition can go very far. So yeah, Logwise really helped in visualization of how much logging was supposed to cost, how much they were doing in terms of this. So logging at this point stopped being abstract and it actually became a design discussion, which you could discuss and improve upon with respect to your peers. And yeah, folks, fun part is this. When logging started to become a unit cost, it really changed behaviors across teams. You should ask people in Razorpay how much logging cost troubles them. All right, from principles to guardrails. Now at this point, we have solid principles, solid design principles. But has anything ever worked without enforcement? Thank you. That's a very strong note. All right. So yeah, if you do not put guardrails in the optimizations that you have already done, it almost always regresses back to ground zero. And we knew this. We know this. We've been in this industry, right? So before even completing all of our design principles, the thought was going in our mind, let's create guardrails very quickly, very fast. So first one that we created was a very proactive and a very simple guardrail. And it was to protect our design principle one, making the intent classification mandatory. How do you stop bad logs from reaching production? Yeah. So we made observability as a formal part of go, no go approval process for any new change or any new application that goes into production. At that time, logging was not something that creeped into production quietly. It actually became a discussion that we could question application teams on politely, but still rigorously. They had to answer very explicit questions about how much log volume were they expecting, why was the reason, what was the reason of that, what is the intent tier that they plan to classify in. It was a lot of back and forth. And finally, when an application went into production, it was clean. That was our assurance. Guardrail 2. Now, what about the applications that already exist in production, but they are introducing new logs? Obviously, let's get the PR reviewed, right? But, log hygiene is a very terrible thing to review manually because you wouldn't know context. You wouldn't know how many times will this loop execute. So how much time will this log statement actually come out? Whether it is a hot API or it is a rare bad job that will get executed, once in 10 days or something. You do not have all of that context. So you will actually not be able to judge what is the impact of this new addition of logging will do to your volume or whether it is useful or not, right? So we created LogLens. LogLens essentially is an AI-based PR reviewer. And very concretely, I'll just quickly take you through what it exactly does. When a PR is opened, LogLens runs like a linter. There is no trigger required, obviously. It identifies new and modified logs, only logs. It ignores rest of the code base. Then it applies deterministic checks first, very clearly that are you logging any sensitive data? Is there a clear log bomb? Is there an info log within, a loop? If there is a clear log bomb, if you're logging sensitive data, all of these are critical checks. And if you fail any critical check, your PR is blocked directly. But after this check, the question still remains. What about the logs that are getting executed in loops? How much cost will they entail me? Are they needed or not? That is still contextual awareness that static checks will not be able to determine. So what do I do in that case? That is when we take help of AI. This system sends AI the log line, the function name, where it sits in the code, the file path, the decorators, and the execution context. What AI tries to do is it estimates a cost range for that particular log line with some confidence. Both of these dimensions are taken into account when we take a decision of whether this log line can go into production or not. So simple decisions, high confidence, high cost, PR blocked, low confidence or moderate cost, warning with a justification. And if either or both of them are low, then we leave an advisory comment. So this gives out very, very actionable outcomes on each PR. Yeah. So that's basically LogLens that we have created. All right. And guardrail 3, log shield. How much do you think proactive guardrails would work? Because there are applications that exist in production, they are continuously logging. What if they accidentally cross the line? I mean, what about the applications that are already present? What do we do? So proactive guardrails can only take you, up a certain place. What about the reactive guardrails? So log shield is essentially about that. A reactive enforcement system for log quotas per application. What is a log quota? Everybody remembers the metric that we just talked about, cost per request, log cost per request. We utilized that. We took that, and on the basis of that, we gave log quotas to each application per day. That took in account of your business criticality, your historical behavior, and yeah, that's about it. And we assign those log quotas to each application. Now, what do we do when an application crosses its quota? In staging, we are directly dropping the logs. No questions asked. You cross the line, you see its effect. That's the kind of reinforcement we wanted. In production, we could not do that. Compliance, right? So we blocked their repositories, the main pain point of each developer. If you cross your log quota in a day, your entire repository gets blocked for further changes. But imagine a company like Razorpay where everybody is, pushing aggressively to GitHub. And at that time, you suddenly get blocked. There are 12 repositories or 13 repositories that are blocked. And everybody's coming down on observability team and DevOps team. Hey, unblock me. Hey, what do I do next? Right? It is chaos. And we did not want that. We wanted, the goal was not punishment. The goal was accountability for what application teams were doing, right? So we wanted it to be a smooth process, and that's why we created Log Shield UI as well. Basically, you will be able to see your application, your current usage, your threshold, your signed units, and everything. When you are blocked, why you were blocked, everything was completely visible here. But even if you know you're blocked, what are the next steps? You would want to say that, all right, I'll fix this, but can you unblock my repository for now? Even to merge the fixed PR, you need the repositories blocked. That is how much of a pain point repository blocking is, right? So as you can see, there is a fixed timeline field. So we have provided that in which you can select from a certain set of dates, which is your commitment that by this time I will have my logging fixed. Once you do that, your repository status goes from blocked to a temp unblocked state. Behind the scenes, there is a job that basically checks for your log quota till the time of your deadline. By the time of your deadline, if you have fixed your logging, well and good. Your repository status goes from temporary unblocked to permanently unblocked. But if you have not, then we moved your repository status from temp unblocked to permanently blocked. What does that entail? That entails something that us developers per se do not like. That entails a RCA. You have to write a huge, nice, heavy RCA. And for multiple violations, you see we are counting, we're keeping account. So if there are multiple violations, there'd be more consequences. But it's all visible. So we gave the teams autonomy to keep their systems clean, but we made our system remember promises. All right. Oh, we'll come to that because I don't want to give away. Right. So now we have talked about the principles and the guardrails and whatever we have done, and we have created a matrix, and we have, created so many guardrails. We have created tooling around it. But what did all of this achieve? Did we just move around numbers, or did it actually do something for us? So in terms of Razorpay, I'd like to show you. Who's you? I am लेफ्ट साइड ही कर रही हूँ सर, नहीं हो रहा है. Yeah, is it moving? All right. So coming back to what did we achieve? Our own metric, cost per request, it came down sustainably by 60%. It came down by 60%, stayed at that. Now, you can see we were not aiming for log volume reduction per se. that came as a byproduct of log correction. And the volume of logs that we reduced was 3.5 petabytes of archival logs that we could clean up. With the intent tiering and the retention life cycles that we could figure out, the monthly storage cost came down by $20,000 per month. And right now it is capped at that. And all of this with no loss of debuggability and query times becoming faster at the time of incident. So this was not log reduction or cost optimization. This was log correctness. And that is the Razorpay story of how log became a problem and then how we solved it. But what next? Now, since we have exhausted so much of our brains around logging, we have put so much into what should exist, what should not exist, whether it should be present or not, and PR reviewer and everything else. What is next for logging? So we tried to exhaust 5% more of our brains. And we actually asked ourselves a very important question. Are logs the right way? Are logs the right primitive for troubleshooting everything? Because if you really want to treat logging as a production system, as a central production system, you want something that can be centrally controlled, right? You see, logs are push-based. An application developer has to decide upfront whether this log will be useful when an incident happens or not, right? And most of the time after incident happens, we add more logs, which circles back to the initial of my talk that, it is chaotic, right? So enters eBPF. Anybody aware of eBPF, what eBPF tech is? All right, great. So thanks. We'll go from here. I'll give you a quick idea of what eBPF tech is. So eBPF tech is essentially something that lets you observe your systems by listening to kernel level calls. If I had to explain you in terms of what we have done, POCs on so far, what essentially happens is, let's say if your applications are running on Kubernetes clusters, your eBPF tech can get deployed, as Demon said, as a sidecar. As Demon said, with your applications, can listen to kernel level calls, can listen to kernel level calls, can fetch all of the metadata. It can get the request, the response, the contextual information around it, and then send it to a storage layer that you can visualize from later. So what happens here is that you're able to see your end-to-end request flow directly, and you will be able to figure out where exactly your request failed, because you are able to see which service received the call, which downstream service actually failed at which point. And all of this without zero code instrumentation, without any need of any code instrumentation. And that is how we want, or going forward, to control troubleshooting. We don't want logs to go away, but we do not want them to be the primary source of troubleshooting. And we want to get our MTTIs and MTTRs up by using eBPF tech. So yeah, that's about it. Yeah, so that was, my talk. I know that I did not mention much of AI here. And since AI is the topic that every conversation is leading to somewhere these days, we learned a hard truth that in observability, you cannot insert AI, right? Because if you have noisy signals, AI becomes super expensive. It's not just confusing, it's super expensive. But when you have clean observability, the possibilities are limitless. And those are the possibilities that my very capable colleague Nehal will be talking about next. Thank you.
Skipping the question because we are running behind the time by around 25 minutes now. Okay. So we'll be getting into the lunch session also because my session will take a bit of your lunch time. But then let's try to wrap up by say 1:20 for the first day. Okay. So I requested him to do closing around 10 minutes or something. They are be fast enough on the quantum side.
Sure, sir. So, hey folks, Nehal here, and I'm a lead DevOps engineer at Razorpay too. I lead the AOps charter. Okay, okay, so while we were actually cleaning up the signals and logs, right, we understood something very important. So, when it comes to an incident, it's not just about the data quality, right? It's more about the data quality. It's the time taken to understand the data, right? So especially when it comes to an incident data point, you cannot just go and run around multiple dashboards. Let's say one is logs, one is on traces, one is on metrics,
and you have Kubernetes related information, AWS information. Like when it comes to an engineer who is going to debug any of this incident, he has to jump into multiple dashboards, discover the information. Like this is going to be the time consuming part of any given incident here, right? So even a clean data might not be able to help us completely when it comes to such situation. Let's say it's around 2 a.m. in the night and it's around Jan 1st, you are enjoying a new year with your friends and families. You get a call from the incident management team. I believe like most of you would have been in this situation, right? So what you would do here, like it's not an issue with your side. You have been called because you're an expert. That's why you've been called 2 a.m. in the night. Already 4 or 5 engineers are already there in the call, like, trying to understand what is going on, and you are called to fast track the issue. So at this point, we realized it is not a problem with the humans actually. So it's a not problem with the engineers here. So with the current state of the tech power we have, this is something which has to be done using AI, and that's how Project Viveka was born. Yes. So basically, Project Viveka deals with a multi-agentic system which will be given access to all the critical systems at Razorpay with perfect guardrails in picture. So immediately when an incident gets triggered, right, Viveka jumps in, exactly figures out what had happened. Maybe again, so just to give a heads up, it's not going to replace the engineer. It is going to fast track the work which they do. It is going to be a guiding hand, helping hand. Instead of the engineer discovering what is going on, they'll be like, okay, this is the context. This is what is going on. Here are the evidences. Take this. I'll give it to you in like less than a minute. Actually, if an engineer jumps on the call around 2 a.m., he has to open the laptop, log in, open all the dashboards, check it. It'll at least take 5 to 10 minutes. Meanwhile, Vivek would have already done it in less than a minute or so. So it will be telling, okay, this is something which had happened. These are the evidences. Take it forward from here. Go ahead and fix the issues because you already have the required data with you here. We had started this project aiming at least 50% of the reduction in the MTTI. So we had onboarded certain services where we already saw a higher MTTI over the past 6 months to 1 year. But when the pilot testing was done, Viveka wasn't able to do 50%. It was able to do more than 90% reduction of the MTTI actually, with a greater than around 70% accuracy during the pilot testing itself, which clearly says AI can do much better if used right. It is not going to replace humans. It is going to be guiding hand here. So we can do much better jobs, and it'll let us sleep peacefully, enjoy a new year, and have good time with our friends and family while AI do the work for us. That's it, folks. Thank you. Yeah. Any questions?
Hello. I have one question. Can you please move to the previous AI slide where you have the ABCD kind of thing?
Previous one.
The flow diagram one. The flow diagram one. Please move back. Move back, well tell. Yeah.
Yeah.
Yeah. So after D, whenever it passes, so it needs more context. So is it something that kind of you are prompt engineering that where it should come?
Correct. All right. So in AI-based peer reviewer, obviously we are not trying to be just smart when we introduce AI into peer reviewers. We are trying to be useful. So if let's say AI is not able to identify the impact or the cost of logging through a PR by whatever information we have provided it actually prompts back to developer to ask certain questions like how many times will this loop run? Is this a hot API? And it takes all of those calculations back into understanding what would be the cost impact, what would be the log volume impact of this PR, and that is how we go about it.
May I have a follow-up? Yeah, since you told that Project Viveka, if we are probably any one of you can answer that, say for example, AI is doing the background work, and if it prompts, then it's a user responsibility to respond. So how it helps?
That's what. These are, I think, two different questions which are trying to solve two different problems. Yeah, I mean, in AI-based peer reviewer, the agenda is different. The goal is different, right? We do not want bad logs getting into production. And for that, we really need to understand what will this entail. And a general review won't do it. And we are taking AI's help to get that understanding. Now, whatever it takes to get that understanding, right? If AI needs to prompt back to a developer, we are ready to get that because we are trying to build that understanding. Whereas in Project Viveka,
Yeah. So again, it's the same in the project Viveka as well. Viveka is not going to into system fix the issues by itself. It is going to be a engineer which is going to check and tell you what exactly has happened. The discoverability part which an engineer will be doing once an incident happens is what is replaced by Viveka. The action items, what exactly has to be done, as a part of the analysis the Viveka is given, that is on the engineers only. So discoverability is done. You need not start with raw data. You can start with the discovered information. You have the context with you. So you can take an action after what Viveka has given to you actually.
Thank you.
Thanks.
One question from my side is on the metrics what you are monitoring, right? So why you haven't considered like how fast an RCA is able to be found out, right? Because you are trying to reduce the logs. In that, when you are trying to remove the noise, probably you are removing important logs as well, right? So why one of the key metric like how fast the RCA is able to be found, why that is not considered?
all right, okay. So first of all, there are always a lot of methods to this madness, right? Everybody wants to optimize. There could be a lot of ways. The way that we figured out was building everything from ground scratch because we went back to our systems, we figured out what we were doing, and we tried to correct it. We tried to log correct it. Obviously, there is a lot of way to measure whether you're logging correctly or not. Are we able to do RCA fast? Is again a metric. How do you think? What is fast for you? Exactly, right? So there has to be a metric, right? So how can I say whether I am able to do RCA fast? It could be like, okay, am I able to do it in a minute? Am I able to do it in a second? I don't know, right? So that is why we figured out a metric that works for us to figure out log hygiene. I mean, that is a great metric to consider and we can definitely think about it going forward. But yeah, that is something that we have not considered yet.
Can I take the next? Sorry.
The question I had, actually two questions I had noted down, but one thing is you categorized all the logs, right, as critical, major, minor. How exactly you accomplished that? Because there's a lot of logs going on in a production system from so many services. I don't know how many services you analyzed.
Right.
And the other thing I had a question was on eBPF. Did you figure out anything for Java or Python? These are interpreted languages, right? How did you do eBPF, anything there?
Right. Okay. So the first question, we have to really scale down to as much minute level that we could get into applications, right? So how do you even tell that whether an application's logs belongs to critical tier or major tier, right? So we have subsystems, and these subsystems are really minor parts of each of our applications, and we decided this tiering at the subsystem level and not at application level. Now to give you an idea, an application can have 25 to 50 subsystems, and we did the tiering on each of this subsystem. How did we do it? It's basically very ad hoc approach because we understood our system. So there was a team that sat down to understand the system, a team of senior principal engineers, a team of lots of DevOps engineers and developers who basically figured out, okay, this subsystems logs belongs to this tier. We basically defined the tier first. We defined the retention policies. We defined what they entailed. And then with full understanding of what it would entail, the consequences of moving a certain subsystem into a certain tier, we took decisions and we did that.
So you literally manually analyzed all the logs
Yeah,
of
I
the
mean,
entire software code base?
yes, it was a quarter-long activity, but as I said, we started on ground zero and we corrected our entire system, is where we stand, what we stand, and we saw the benefits that we saw. Yeah. And the second question was around eBPF.
eBPF
right?
for interpreted languages like Java.
Correct, right? So we did not, the subsystem that they're talking about is the service. So we categorize services into those categories, and all the logs inside the service check out the
Okay. The entire log pool from a particular service is in a particular category.
All right. And regarding eBPF, now eBPF is a tech that, deeply interests us, right? Because it is without any code instrumentation. And, traditionally eBPF is only used for network observability. and performance observability, like in network where your request is failing. But there have been companies that have built platforms on top of this tech, and they're able to tell you up till a function call where your request has failed. So we are exploring something like that. It's called Odigos. Currently, we are running a POC on it. And yeah, it's pretty powerful, but we will have more to talk about it probably when we have completed it.
Which eBPF tool you're using?
Odigos.
Odigos.
ODIGOS. Odigos.
Launch will be delayed by half an hour, more or less. Thanks to Sejal and Mehul for Nehal. So, round of applause. This was quite a big. Doing observability in a fintech, which is heavily regulated, is not easy. So, last talk for the first session is on me, and forgive me if I disappoint you. Forgive me if I disappoint you a lot. I'll try to share my screen and see if it works. Let's see if it comes. Yeah, okay. Which screen it came? Okay, I think we are there. So the issue is, how many of you have seen this movie, Oppenheimer? Still 15%, not like 100% hands. So if you get a chance, do see it. I start from there. So who am I? Debanshu Saha. I think I introduced myself at the beginning. Right now, I work for a company called MHP. It's a Porsche company. It's a consulting wing of Porsche. So we look into different manufacturing automation at one side, and then managing bunch of things outside the managing units, like vendor management and all those stuff. And predominantly, these businesses were on their own cloud infrastructure within the company premises, majorly on-premise. And the charter that we are trying to move is doing a lot of things to the cloud. And at the same time, we are a premium partner in the sense consulting partner of AWS. So my previous role at AWS is helping a bit here and there. Career-wise, 50% of my career was in Indian public sector, Government of India, Government of West Bengal. Then I moved to Yahoo, where this all LSP thing got created, roughly around 8 years. Then 6 years in Samsung, 4 years at Amazon. And then recently I started with MHP. So that's all. I have a lot of friends here and there, worked with me in different organizations. Dinil was at Samsung, Hemant was in Amazon. And now let's try to stick to the point. What exactly is this quantum computing and where it came from? So we talk about why I started with this Oppenheimer movie, because this movie captures the essence of what we call the first quantum revolution. Okay, so last year, 2025, UN declared that as the year of quantum technology. It was a United Nations program, and then every country was contributing to it in different ways. We'll talk about where India is poised as of now, along with the program. But if you see, the first revolution had two things majorly. One thing we understood very clearly is these subatomic systems are not deterministic. These are all probabilistic systems. Okay, that's the first thing that we understood. The second thing that we understood is macro behavior of this subatomic systems. What it means is, say, for example, we understood photoelectricity in 1905. Okay, but the exact explanation of photoelectricity didn't come out. Then we started understanding the band theory of solids, and something jumps from an intermediate band, then it can be a electricity wavelength or something of light wavelength kind of a scenario. So these are basically quantum effects in bulk that we understood. What are the outcomes? Any guess? I mean, the slide is up there, so there is no guess, point of guess. So all of microelectronics came out of this first quantum revolution. So your MOSFET, which is the core of a CPU and all, everything came out of it. The other thing, in good and bad both ways, it came out, and which is atomic energy. I mean, without more or less atomic energy, today's electricity demand will not be met. That's one part. But then we had a disaster at Hiroshima and Nagasaki with atom bombs hurled upon them. So both sides of the story. Now, these were stories until 1970, because physicists intentionally, there was a large project with the physicists, the CERN, the superconducting supercollider, where they wanted the beams to work and fuse in a nuclear fission kind of thing and do a lot of things, but that didn't get a lot of funding. The reason being, most probably the powers who had money felt that, well, this is not going to give another bomb. And anyway, we are not trying to make another bomb. So superconducting supercollider didn't get a lot of funding, though CERN is managing that, and that's where hadron colliders and all these things has came up later. But then the different sort of physicists started thinking in a little bit different way. And that's what started the second quantum revolution. What second quantum revolution actually encompasses? It's active manipulation of individual quantum state. Okay, we'll come to quantum state in a bit without touching the maths of it, because the maths is really, really deep. And then superposition of states, creating multiple states. That's where the quantum advantage comes. We'll talk about it in a moment. And then the other thing, which is very important, is something called entanglement. So basically, multiple quantum state, we entangle them, and then if you separate them far away, they still remains entangled. You can't really imagine this from our normal senses, because this is very micro. Okay, you can't see it. So if you don't see, we don't really visualize what's happening. It has kind of a sixth sense thingy, but then we have experimental evidences of entangled states. People have experimented it now, and those are evidences which we need to believe, more or less. Okay, so what is the disruption out of the second quantum revolution? Obviously, quantum computing is the disruption, which we are going to talk a bit in a very short manner. But there are other disruptions. Means if you go to a physics laboratory, high-end physics laboratory, we are not very far from Indian Institute of Sciences. There are at least 3 laboratories who are really doing deep application of this second quantum revolution. A layer of atom is being manipulated with targeted lasers and stuff. Just opposite to IISc is Raman Research Institute. Okay, a lady, a researcher there, Professor Urvashi Sinha, got named under the first 100 contributor in quantum computing for 2025. So they released a list, and there are 3 Indians up there in that list, and Urvashi Sinha is one of them, who is with Raman Research Institute. Okay, moving on. Keep this thing in mind. I am not getting into the mathematics of it, but this picture is pretty important and forms the core of what we call as quantum computing. On the left, black, something called qubit. For classical computing, you all know it's a bit. how we create a bit, it's a state of voltage, most of the cases in MOSFETs. That's how you create state. These are qubits. Okay, qubits are not two-state system. So you see a vector, we call this ket psi. So there is a notation created by Paul Dirac, one of the brightest mind during first quantum revolution. There's entire set of notation around it. This is called bracket notation. And this ket is a representation of a vector ket, which is state of a system defined by psi. For example, think of a classical thing, velocity, v, u plus ft. You learned it in early days. The instantaneous velocity of an object is initial velocity plus acceleration into time it has accelerated, right? The similar way, this is the state of a system, psi t. But how we represent it, that's the equation. It took 15 minutes to write this equation in a equation editor to early today. For me, it is very difficult to write these things, and I actually bought a handwriting pad through which I can write. So this is called a fundamental equation of state or a single qubit. Psi is a single qubit, and it is alpha ket 0 plus beta ket 1. You look at the picture on the left. On the z-axis, this is called ket 0 axis. This is called computational basis. Some sort of terminology. This is called a computational basis on which the ket 0 lies on z-axis, and in the opposite side lies ket 1, which is on minus z. And why something is like that? Because we had the rectangular Cartesian system, which looks a little bit different. Now, there are a lot of mathematical discussions around it, so let's not get into it because I'm blocking you between lunch and this. Okay, so let's not waste time into dry mathematics. It will be diff, and without a chalk and board, it's difficult to explain. Okay, so here it is. The ket psi, the superposition state, is alpha ket 0 plus beta ket 1. What are these alphas and betas? The alphas and betas, this is where quantum computing differs from classical. These are complex numbers. Okay, there's only one condition on alpha and beta. Modulus of alpha square plus beta square, it has to be 1 always. Okay, now you see the possibility of how many alphas and betas can be there. So you can imagine the state now with varying alpha and beta. See the vector, and it just moves into the sphere, and it changes, and the state changes. The advantage of second quantum revolution is today we have technologies to control this state of a single qubit in a precise way. Okay, there are timescale challenges, and all will come to it in a moment. A bit of history. I was saying that in the first 30 years of second quantum revolution, where quantum computing is involved, there are multiple thought processes. In 1970, the first phrase is Charlie Bennett, who defined the term quantum information theory. Those of you from quantum computing, computer science, not quantum computing, computer science background, you must have heard of Turing machine and all those stuff. This is core, which forms the theoretical core of computer science. Now, Charles Bennett is the first person who started talking about quantum information theory, not the classical information theory. So 80s, Benioff, Feynman, these are people in Caltech, Berkeley. They started talking in terms of the limits of classical computer. They started saying nature is quantum. So to emulate nature, you actually need quantum computers, not the classical ones. Okay, a bit of yearly. You see you just look at the chart. 1970 it started. 80 is when Bennett is saying that there could be a Turing machine analog using quantum computers. Okay, 84 BB84 is a protocol which is like now cryptography is is at stake when Shor's algorithm is trying to say that it is breakable. BB84 was a secure protocol which people demonstrated in 84. This was one of the revolutions in quantum computing space. Okay, 94 is when 10 years later, BB84 is coming in 84, 94. Peter Shor is coming up with an algorithm which will use quantum computers when it is available. What it can do? It can do integer factorization in polynomial time. In today, if you check classical algorithms and all with classical computer, it is exponentially complex, and we'll break it in polynomial time. So you see the difference. So actually they demonstrated it with a 15-digit integer, and that actually shattered the armies and militaries and defense and all those things, because they knew most of the cryptography is dependent on RSAs and stuff, which is integer factorization. And if integer factorization happens in real time, then there is no secrecy. Somebody trespassing, getting your line, they know what secrets you are discussing. So defense was actually shaken from that aspect. So 1997, Paul Grover is obviously an Indian. He came up with an algorithm which is called Grover's search. What it does, search is basically once again an exponentially complex domain. Okay, Grover's search gave a way it is polynomially complex. So you can differentiate the time complexity changes in order of magnitude and stuff. 1998 is the first 2-qubit physical qubit quantum computer got achieved. It's IBM. I will just go to the next slide in how we are moving. Fast forward, that was the first 30 years, 70 to 2000. 2000 to now, after 2020, we were calling it as a quantum decade. Why? I have given some of the stories there. So by 2012, people understood that we need some sort of clouds so that people can come up and practice this. And this is around the time when IBM Compute Quantum came into existence. Okay, so you don't have to catch all those slides. I will share those in our Discord channel later. So everything, entire deck will be shared in our Discord channel. So you can listen and just. And now see the challenge was to get a stable quantum computer with large enough qubit. 1000 was a milestone. If you get a 1000 qubit quantum computer, then you have enormous power. Why? For example, to represent entanglement, you need 254 classical beats. Okay, we are not going deep into the entanglement. There are gates operations and all. Just think of the same, 254. And how many qubits? 3. You see, 3 order of magnitude difference is where these things comes. So if you today have a CPU which is certain gigahertz and all those stuff, with say a 64-bit CPU, which is basically the size of your registers, and we are talking about 1000 qubit computer, infinite state, and all those stuff. Okay, and we see how IBM progressed. There are different companies. We'll go to that in a short while. 2019 is a 27 qubit IBM computer, Falcon, and then 2025, let's jump back a little bit. 2023 Condor was a 1123 qubit computer. Basically, IBM has reached that 1000 qubit milestone, but there were problems. These qubits were theoretically there, but then all these qubits were not available for actual calculation, actual state management and all. These are state of a computing generation, quantum computing generation, which we call NISQ. Okay, noisy intermediate state quantum computing. Okay, NISQ. Okay, from there, our primary challenge was how we mitigate the errors. Okay, how the error correction can be done. See, if you think of error correction, we are not really thinking about how classical computers do error correction. For example, you tap your keyboard, there are noise which goes to the computer. But then computers eliminate those errors and identify if you pushed Q, it's a Q. Okay. Now quantum computer doesn't have that. It has to build all these things. So these are the things where from the typical things started coming up. So now where it can be used, quantum computers, okay, somebody said, some physicists said, is it really useful? So there are three pillars of problem solving. If you I've kind of hinted earlier also, simulation. So those of you who have some inclination towards biology, molecular simulation is the thing which you need to design a drug. If tomorrow a new antibiotic needs to come to the market, it has to be designed, then researched, then marketed. Lot of trials and all. Now, these are very, very computationally heavy challenges. Protein folding, for simple, think of a protein with n-dimensional forces working on different molecules and all. Manipulating those things, predicting how it will work is very difficult, very complex mathematical problem. So simulation is one place where quantum computers is the need of an hour as of now. Every biologist you go who are in drug design, and if you ask them, I have a stable quantum computer with 126 active qubit, they will jump onto it and try to create it there. Okay, search and graph optimization, all of you know how complex it is, and more computing power, how it can help. Okay. Bunch of folks, I think there is a person who came from data science background. So ML and AI, you know today what is the limit of training complexity, right? So the moment you get a quantum computer in between, half of your problem is actually solved. Okay. So cryptography and security, we started with BB84 and SHOR. Now, you see, Google has said that it has migrated to post-quantum cryptography. What it means, they are no more using RSAs or some algorithm which is around the integer factorization, dependent on the integer factorization. Some sort of algorithm which is not dependent on it. They have migrated, but tons of government agencies, they are not a tech company. They can't change their algorithm. A cipher today in India or any other country per se, there are 2 copies of cipher set. If one is compromised, entire country has to destroy the set. Okay, how I mean, authoritatively tell it because I worked in government, so I know the procedure. The entire set of ciphers, if one is compromised, has to be destroyed. And you are on the second set of cipher. So it's a quite a long process where to change something within government, a crypto system of something, it will take a lot of time. Okay, Krishnendu has already in, and I'm pretty much sure he is thinking, okay, this fellow, I'll take him after lunch. Okay, because he is talking about security, the post-lunch session. So current economic value, this is a figure I have taken from a slide that IBM has, 168 pages. This is called a quantum decade. You can download it and read it, and you will see. Now, Trinity Tech is a new term that people are talking about, which is supercomputing using quantum computers. So quantum computers is at the center. There are classical computers here. There are other sensors here, and then AI neurons on the right side. So that's an entire ecosystem people are talking about while talking about this trinity of tech, Q-centric quantum supercomputing. Now, obviously, the expectation from quantum hardware is pretty straightforward, right? You should solve complicated stuff and which cannot be solved classically. This is the standard expectation. Now, what's needed for that is quantum computers large enough to run complicated calculation and make few errors. Simple, not more than that. But what it means is qubit needs to be in its state for longer. We were talking about manipulating a qubit state, which is a single atom in some direction. Okay, now these are perturbed by temperature, these are perturbed by magnetic field, these are perturbed by electric field and all those things. Okay, so a millisecond is needed for a state operation on this part to get a result out. Okay. But if the circuit is noisy, we call this decoherence. If the circuit is decoherent to the order of less time than the quantum operation time, gate operation time, then it's not a stable quantum computer. So basically, to make a stable quantum computer, you need coherence in the qubits for a longer duration of time than compared to the gate operations, multiple gate operations. Obviously, a single gate operations will not give you a computational result in one shot. It needs to be. So demonstrate decoherence. Controlled operation can happen resulting in calculation, and decoherence should result in measurement, merger, classical state showing result in a different way. So basically, you need to have a coherent state of qubits. So how about error correction? Because we are talking about error correction. Now, we are talking about single qubits, error in single qubit. Is there another qubit which is in stable state? Can I transfer my transfer my quantum state to that qubit? Okay. So the new ways of doing it is they're talking about cluster qubits. Say, I was giving example of one quantum computer which IBM brought had 1023 qubit, but not all qubits were usable because things were decohering. So effectively you get very less number of qubits, which is effective. So now what people are trying to build is, okay, I will make a 1000 qubit physical qubit computer, but among that physical qubit, available operational qubit will be number of cluster qubits. I'll take say 20 qubits to represent one state, so that if decoherence happens within that 20, 1 or 2, I will transfer that to other. So this is the error correction, error mitigation techniques that people are talking about, and this is called a cluster operation of the qubits. Okay, now little bit of physics here. Now, what are the technologies? This is the most stable one, superconducting circuits. Okay, you have what is the time? Okay, now we need to run a little bit faster. This slide will be shared. So just think about Mota strengths are, this is a mature technology. And what are the companies doing the super quantum computers with superconducting circuits? IBM, Google, Rigetti, and Alice and Bob is another company which I found the name. I don't know a lot about them. Okay, then trapped ion. Ion are have charges. You remember that from olden days. A trapped ion is basically you trap an ion in an encapsulated electromagnetic field and then you manipulate the state, right? So advantage, high qubit fidelity and long coherence time. We are talking about coherence time matters. So that's where it is. Okay, weakness is slower gate operation. So if you run a Hadamard gate to change a state, it takes a bit longer time than that compared to the superconducting circuits. Only IonQ, to my understanding, there may be other companies, but I know about IonQ who is doing this. Neutral atoms, you obviously neutral, so no effect of electric and magnetic fields per se on them. So once again, coherence time is higher because it's not impacted with electromagnetic fields. The companies, there are multiple companies, Qvera, Atom Computing, Pascal Computing. I think Pascal, I wrote the correct spelling, maybe some error. These are companies who are doing this tech for quantum computers. Photonic qubits, most promising as of today. If you visit IISc, at least there are 2 laboratories who is doing photonic experiments for communication on one quantum communication. It will not be impacted. So you just need very minuscule mirrors, minuscule lenses, lasers, and all those stuff. And Psi Quantum, and they are collaborating global foundries to bring all these mirrors and stuff so that they can do a lot of photonic qubits. And in Australia, I think they may go to 1000 qubit photonic quantum computer pretty short. Okay, topological qubits became like mainstream media when Microsoft talked about Mozoroma some time back. lot of deep physics. The concept is not new, obviously, but the way the announcement came was a little bit misleading. The community didn't believe scientists, almost like telling, okay, marijuana or mozarona, what are the things that you are talking about? Okay, so we'll move on. What is the ecosystem in India? The Indian ecosystem, India has launched something called National Quantum Mission. Over a period of 6 years, there'll be 6,000 crore. I'll show the site of it in a moment. I'll try to project that. So 6,000 crore budgeted, and there are 4 pillars doing it, with Kanpur IIT being the moderator. They're the coordinating institute. And then IIT Madras is doing sensing. There are 3 other things which different institutes are doing. And the most emphasis that they are putting is building skills. Okay, so there are faculty development programs so that faculties can teach their students about quantum computing. Some of your teachers, I mean, those who came from colleges, maybe in those faculty development programs. For some of us, we did some certification from IIT Delhi. They were running a course on quantum machine learning some time back. Now, Roorkee is offering another similar course. Most probably 2026 you will see it. So these are a lot of capability building thing, because this needs reskilling, serious reskilling is needed. Karnataka Quantum Mission is another program, okay, which was launched or announced in Quantum Bangalore, which was in November 2025. We are talking about building almost like 1.3 billion quantum economy by 2035. Okay, these are obviously projections, but a lot of people are actually working. We have groups and communities where jobs related to quantum computing are coming up. These are mostly research and stuff, but then there are postings. So today, what we can do? A lot of discussions and stuff. Design and test solutions. Run hybrid classical computers. You have emulators, which I'll try to show. Do small proof of concepts, and then push boundaries of classical methods and identify potential NISQ. So if your problem can be addressed in a NISQ era, you can take it out. But because you have to start, if you are in a deciding role, you have to start investing here. Okay, and tomorrow, obviously, larger early applications. First demonstration of the commercially relevant solutions. Somebody is talking about portfolio optimization. There's an algorithm called Cubo, which multiple universities are actually trying. And these financial companies, I'm pretty much sure Razorpay will follow path. Like Morgan Stanley and all, they're into it. They're the primary investors in this area. Eventually, what we need is a full fault-tolerant quantum computers. That's the need of the hour. The ecosystem, what's there for us to try and do something. Okay, one is IBM Qiskit demo I have planned. Let's have the lunch and then probably we'll do the demo. Okay, this is an emulator which runs on my computer, so it's not very difficult to run. And you will find a little bit of interest there. Okay, IBM Quantum, once again, spelling mistake. I just make it A. Is a platform. You go and register. You will get 10 minutes of quantum computing per month. So you can use it for your own learning, and it's all free. Emulator, I don't advise, you guys are all techies. I advise you to run on your own laptop, not on a platform. QBRate is a new platform which is coming, global collaboration. All the cloud providers who has a quantum computing offering are connected to QBRate backend. So you will see IonQ, you will see Amazon Bracket, you will see Google, you will see IBM, everything you can connect from there. You need to have your quota purchased from separately, then you connect the APIs and then you work from the same platform. So that's an advantageous thing. CDAC also has a new portal. Okay, but it is only emulator. It does not have a quantum computer in its behind it yet. But then the emulator runs on their supercomputers, the CDAX supercomputers, which is there in Bangalore, also in Pune as well. So you can use it if you want to try and learn all those things. Okay. Resources. Unfortunately, you have to learn a lot of mathematics. Okay, you can't escape doing this. These are some of the books that I usually refer. My favorite is Feynman, obviously. But then the other thing, which is Leonard Susskind, is an interesting book to read now. Okay, on the right side, National Quantum Mission, if you want to understand the theme of it, read Venkat Subramaniam. He recently left IBM. He was leading the quantum team in IBM. He recently left. Most probably he will join somewhere. We have to watch. But he is closely working with the AP's mission in Chandrababu Naidu's task force to do quantum computing hub in Amaravati. Okay. The other book, the publication date is 2026, but I got a copy in 2025 from Amazon itself, is from Mustafizur. Mustafizur is a extremely hands-on scientist who works for IBM quantum team. Okay, he at times travels in Bangalore as well, but majorly works from Calcutta. Decent guy, approachable, available on LinkedIn. Just ping him. And this book, you can buy it. I can recommend it. I have gone through half of it, and pretty decent book and accessible, $500 or something. So you can get to start this with IBM Quantum platform and an emulator on you. So with this, there are references. I will share the slide. So not an issue at all. Do join our Discord group. And I have the demo with me, but it is 20 minutes behind lunch. So we'll have the lunch, and if we connect after probably the last talk, we'll show the demo if you still have interest. Thank you very much. Any questions?
Now, I just had what all you spoke to me, right? I have very concerning actually the way how this is progressing, computing. What I'm worried about is many of us use cryptography tokens and all those, right? Like if I use AES, now, 2-bit is, if I have relay, it's like basically instead of Bitcoin, you use your broker. Like the field ratio is running on Bitcoin, right? So right now, in qubit, they use qubit quantum computing to have video tokens. Because there's no limit on that one. So if this gets working, what I'm worried about is people who are using all this
RSAs and stuff.
the security tokens and all that, they can, but they can decrypt it. Because it becomes a lot of security. My question to you is, if it is a threat, people using by wrong use cases where they use for, decrypting the key.
So not only you, actually all the defense establishments are actually under deep pressure. I can tell you at least 4 funding, 2 in IIT Delhi, 2 in IISc Bangalore, 2 in CDAC Pune, that DRDO has given to have the QKD, quantum cryptography, enabled for the communication channels. Okay, people have tested this with, so basically we used entangled qubits to do QKD. So people have tested it roughly around 400 kilometers of fiber optic cable as of now. I've seen this experimental setup in IISc. Okay, but then I'm not very sure how far they have tested it over satellite channels and stuff. So those things needs to be seen where it stands today. But to your point, every defense establishment is more worried than us. हम लोगों का तो 2-4 पैसा चला जाएगा, मगर उन लोगों का तो national secret चला जाएगा. So they are really scared on it. This is public knowledge, Srinivas. There can be non-public knowledge where people may have already 1000 qubit stable quantum computer and they are decrypting your stuff. Yeah, go ahead.
Classic, just for the sake of audience here, just to oversimplify classical computing and quantum computing, I can be wrong, but that's just an analogy that I'm drawing. Think of one key you have to find behind that is hidden behind 10 doors. So in classical computing, basically the CPU will go and find the key by opening one door at a time and then execute it. Quantum computing, you find that one key is hidden, 10 operations done at once.
Correct.
Now this is taking this as a reference, that's a post-quantum cryptography like this. How does it is going to be in next 5 to 10 years? How do you see that? Like,
well, 5 to 10 years, not 10 years, maybe another 4 years, you are still okay, because all the predictions, whichever you have, will not have a very stable, say 1000 qubit quantum computer before 2029. That is the pace of technology today, because because we are manipulating signals, so everything is very complex. So achieving that is not. But beyond that, there has to be fundamental changes in the way we do crypto today. There has to be fundamental changes. They are talking about PQC with algorithms which doesn't use integer factorization. But the parabolic and elliptic stuff that they do, they are also computationally complex to a computing principle. Now, if quantum computers tomorrow come out with a different paradigm of computing, then they can be at stake as well. Okay, so until 5 years, most probably we are okay, but there has to be fundamentally different thinking coming around on how we do security, number one. And commercial applications are different sorts, right?
Yeah.
People are primarily worried about security because national secrets needs to be safeguarded.
Yeah. Thanks.
Thank you. Thank you. Yeah. Last question. Very deep concept. That has been more or less proved to be incorrect. Okay, as of now. So you have to go through some papers. Qiskit basically has a way to emulate quantum teleportation. Okay, you can see your qubits teleported and remaining the state when it is entangled. Basically, how people do it today is you entangle the qubit and then teleport it.
Exactly.
So the entangled state remains. Exactly. So you start playing with Qiskit. There are available routines which can demonstrate a part of it. And people are talking about, they have done those experiments more or less successfully in a scaled down version of a system. So how exactly it will be used when, for example, now people are planning to go to space as a travel tourism thingy and all. So those things will come later, but scaled down versions you will probably see in another 2-3 years that people are talking about. It will be like the way you call an API, you will be calling a teleportation system, something of that sort.
Exactly.
Yeah, sure.
So with quantum computing, right, I've seen students are also here and a lot of people have come for the talk. But then it sounds very fancy for people who are not very much into it. So what should be the approach of people who are newer to this, right? So how should they start testing this field, or what should they start learning from?
Yeah, so I had the plan to get you excited so that you can start the experiment on your laptop right now. So we'll do it after the last session, probably for 15-20 minutes it will take. So route number 1, start exploring Qiskit and the small problems. Qiskit has some programs on Fall Fest, Developer Association, and all those things. You can get to those. It's all open source. Nothing is hidden, so you can get it. I was participating in IISc's Qiskit Fall Fest, which last December, early December. And people, actually, these are meant for students primarily. We professionals are like third parties there, don't get priority, but students are the priority there. So you can start experiment. Point number 2, you have to get into matrix mathematics, probability and stuff. The book I showed for Mustafizur covers the spectrum of mathematics that you need to master to get a hands-on feel of it. So you can't escape mathematics to do quantum computing. I'm sorry to say that, but that's what the truth is. So we have to make our hands dirty into this field. Okay, thank you for patient listening. Let's get into food. Whether Krishnandu will allow us to keep it somewhere later, but as of now, you have to learn it by sitting deep into this talk. Okay, over to you, Krishnandu Square.
Hello guys, I think I'm audible. Hello, I'm audible? Now? Yeah. Sure. So I'm Christian Dupal and here.
Most of you know me.
Yeah.
Regular to LSP.
So, yeah. So people call me KP and he is KD, right? So it is easier to remember. Hello. So thanks to lspe to inviting us for a demonstration over here regarding security. I know you guys are gurus of large scale computing and quantum and whatnot. My task is breaking those things in a basic way, in a human way. Because even if we are talking about quantum, even if we are talking about any technology, that comes fast. And then a simple 15 years old kiddos break that without using quantum and without using anything, just based on human knowledge. Just calculating 1 + 1, 2 and creating some kill chain, we call it kill chain, based on that. So it will be a very basic demonstration. First, let me introduce us.
Yeah, so I'm Krishnandu Das, currently working for Lenovo as an engineer. So already I think Devangsuda like introduced us. Thank you, Devangsuda, for the invite. And yeah, so
yes, I am Krishnandu Pal. I'm presently working in Ericsson as a red teamer. I am leading red team of Ericsson Global, and I have more than 20 years experience. And by chance, my experience is mostly on offensive security. Like wherever I worked before, I worked something like breaking things rather than creating things. Though I am very much open source enthusiast, I always remove my router firmware and deploy open source software like OpenWRT. Right? I don't like closed source because I think there are more power in open source rather than using your closed source router or closed source devices with its default setting, right? So here we comes open source, right? If some people think open source is very vulnerable because source codes are open. Few people think Linux is very secure because of the architecture, because of the design and everything. But again, are you sure? By default, even people tell, okay, if you are doing default setting, then it is taking default setting, then it is unsecure. So you have to configure it to make it secure. So what people are doing, they are going through SOPs. This is the way to go forward. And they are configuring their Linux servers using that SOP defined by some senior Linux administrator or architect, and thinking that, yes, we are secure because we have implemented these and that. We made the permission very secure. We added sudo and whatnot, right? And then we are thinking we are secure because we followed the procedure without even understanding what it does. Next. So first, let me introduce you to a hacker mind. Hackers, in a sense, malicious intruder, it is more prominent word for it because hackers means something else. So how they think, there's a very confusing area, because if you are looking at only our country, there are more than 400,000 or more than open jobs are there. There are no experts, but still we are having our geniuses like from IITs, from ISCs, and many other places, but very rarely you find a hacker. To be precise, in India, if you are looking at technical aspect of it, technical understanding, who actually can break things, the numbers are merely 5,000 or something more. Not more than that in a country of 120 crore or more people. So let's go to the next slide. So let me give you a scenario so you can understand what and how hackers think. So scenario is, you are a agent, spy agent, right? In your city, say from a rival country, another spy came over here. He's going to stay here for long. He is staying in a hotel. So he left a hard drive in a bedside table and secured it with two locks. One is numbering lock. One is padlock, means key and lock. Now, these kind of two locks you have seen multiple times, right? It is a bedside table. So your target, next please. So you have professional knowledge, documentation, and everything. It is a scenario, right? So you have already tried how to break the locks, how to break the numbering lock. So you have all the documents, all the tools in your hand, and you have, if you you have 24 hours in your hand to break the lock and get the hard drive. So main task is getting the hard drive, right? So which lock would you attempt to open first? Numbering lock or the padlock? It's the question to you. 1, 2, you can answer you can share your mind. How you think you are going to break that lock? Huh? Any reason? So yeah. States of the combination, right? Easier to break. Any other? Padlock. Any reason? No, you cannot break it. You have to open it, right? With the key. Okay, understood. So if I am taking it to digital world, what I said, that which lock you will open to get the hard drive, it is what corporates are doing, right? Corporates are telling, okay, I have put a firewall. This is the WAF, web application firewall, and I have these and that. But let me share what hackers are thinking. So these are the scenarios. I told a bedside table. Commonly, a bedside tables have multiple drawers. I never told which drawer I kept the hard drive. So if you have put it the hard drive here in the down locker, I never told which locker it is, right? You can open the drawer. Again, I think it's visible, right? The photo is visible? Yeah. So you can open the upper drawer, put your hand, you don't need to open the lock. So hackers think in this way. They don't break locks. They don't think about keys, quantum, encryption. Yes, researchers are thinking those attacks are very high kind of attack. Nobody thinks about that. So let's begin with the attack. We are going to do in a two-way. One is demonstration, and yes, with obviously presentation as well. So first we will show, you say like you are having you are having a computer in your local machine, local, network. Now you want to give access to your account, some other friend, but your SSH is not enabled. So remotely from the same LAN, nobody can connect to the system, right? You are feeling secure. So even if you are giving your login name password, until and unless somebody is coming to your laptop or desktop, he or she cannot log into the system, right? Because there is no remote connections available. So let's think about a way. It is a Bob user in Linux. Is it visible? Yeah. So it is a Bob user, common user. Say like he's a developer. He wants somebody else to give access to his system, and his system is not running SSH. Say it is running SSH to for demonstration purpose, but say it is not running SSH. Now there are multiple ways. I am showing you fast. cpan. cpan is a by default application installed on your Linux distro, which is a PAL library installer. So if you can install PAL modules using cpan, it is by default installed. So what we are doing reverse shell. Rather, I am connecting, like the hacker is connecting to the victim system. It is ulta. Victim is giving a reverse shell to the hacker. It can be done by NC and many other commands as well. But NC means netcat is the easiest way to do it. So what we are doing, So what we are doing, we are running NC on my Windows laptop and running is a different network, right? Altogether, a different system. So we are running listener, listener on this my Windows laptop, and on the Linux server, we have defined the remote connection host and remote connection port. NC is listening to 9000 port as well. Go to the, now execute the command. Open the cpan. Now cpan. Why? Now I'm pasting a code. It is already coded. You will be having access to that slide I have shared. So you can know. Not PAL interpreter, is a PAL library installer like pip3. PIP for Python, right? Yeah, cpan is having internal cell. So when you are not giving the command, you can do. Yeah. So we have created a socket, like we ran a Perl script inside cpan. So what is happening? Go to NC. Now it is connecting to my host, Windows host, via reverse shell. Now type ID. Look, I have the full access as a Bob user to that system without having SSH or any other remote connection available. I am having just my server access. I'm giving permission to somebody else. Yeah, this is the like basic scenario. If I am taking it further as a hacker killchain, I am dropping into a shell via web application exploit. I will be sharing the code later on. So it is opening the TCP socket on that port. That's all. Yeah, on that port. It is mounting that, right? Bypass. It is bypass because cpan by default is giving you Perl access. No? Yeah. So what is doing? This machine is connecting back to that hacker system. Yeah, these are listening. Means that is on the Bob system. Bob. So this is the Bob system, right? So let's say like system A.
This one is, where is it getting executed?
It is executed on this Linux system only. Yes. It is mounting /bin/sh on the listen back IP, right? So whenever it is listening back to, like, when connecting to the remote server.
That's what.
Yeah. So this is just one demonstration. Next. Don't make it complex. Don't make it complex. We are using common commands. cpan is not there. Understood. It may be possible that administrator removed cpan. What about AWK? Control. Exit করে দেবে। Double control দিবা। সেট কানেক্ট করে নাও ভাই ভাই। অথবা Control C L মেরে দে। এই Control C। Now, no, slide ঠিক আছে, okay. Now come to if cpan is not there. Okay, understood. But do you have access to AWK? Commonly, yes, right? Huh? Oh, okay. Yeah. So next. NC chaline abar NC chaline. So even we are running NC listener on the same port. Again, it is an attacker machine. So now with what the same thing we are doing with AWK, but using TCP socket of Linux system itself, because cpan is not there. Enter. Pardon me? Ye wala is waiting, just waiting time for. It's looping only for looping the section. Yeah, must like it is of view. It can increase and decrease. It is there are other ways as well. Okay, let me show the. Not that complex area. Okay, let's go to other. This one is done. Like again, it is shell. So go to exit. ID. Okay, you don't have access to the AWK as well, right? Taking is granted that AWK is also not working. এটা বন্ধ করা হবে হয়নি বন্ধ হয়নি এ ব্রেক হয়ে যাবে এনসি চালাও ব্রেক হয়ে গেছে So let's try with pure bash. I'm not using AWK, not using any program, just opening a TCP socket to that port. Let's check what we get. Again, we in shell. You don't have access to cpan, you don't have access to anything, but bash, yes, bash is there, right? So it is enough. Okay, let's move on to the next demonstration. এটা খুলে দে না না the presentation sudo. Now let's talk about sudo, right? We all know we make our system secure using sudo. By default, any Linux installation nowadays don't give you root access. Rather, you go for the user account first, then sudo it to get the root. So here, I am typing the sudo rules over, like, testing the sudo rules which is given to the user. So this is the sudo rule. Can somebody, Linux administrator, who is confident and come check over there if anything we have done wrong or not? Anybody? Or I think everybody can see it, right? Is it visible? In between, let's go to the presentation again. So everything is there. We will be sharing the presentation after event is done. Also with the explanation. So later on, now come to sudo, right? Sudo is making your system secure. It is what you think, but yes, there can be breach of sudo rules as well if it is not programmed well. So we are going for the demonstration of it. Go to the next slide. So we are using fast two very basic option. Why sudo use nowadays use to giving access to the developer in DevOps scenarios, so they can use a programmer developer can use Git to download something or push their repository and all, right? So say if you are given access to Git to to the developer, now the developer want to exploit the root access of that system. How it can be done? Demonstration. Bob. sudo minus ida issue में लिख देखेंगे एक बार. So let me show you by typing by default sudo minus l, sudo minus su, and sudo minus. So it is not having access to the sudo minus I. It cannot go to root shell. Sudo su. Sudo su is not possible as well because it is not given access in sudo. So they cannot go to root shell. Now go to Git. It is the developer. It is having access to Git using sudo. Now I open the man page for status page of Git, right? Exclamation. Exclamation. Again, exclamation. So back for exclamation. Bean দুটো পড়ে গেছে exclamation. So root because I went through sudo git. Git is running with root access because that is not connected with the user account directly. It is given via sudo access. So if I am bypassing that man page which is opening in VI and dropping execution command by putting an exclamation sign, it is actually executing /bin/bash or whatever command I have given, right? So it is dropping me on root shell directly, whereas VI. No, no, actually same thing. Like if VI having the option, right? / by default it is VI only. So you have to think in that way, right? If I want to secure, I have to remove the man pages and I have to change the default editor to these and that, right? Sudo VI. No, VI is itself not vulnerable. So VI is user access.
User Bob may run the following command, it says, no, on val_ns.
Yeah, but Git is running as a root user, but VI is running as /user/bin/these user. So VI is for all. Git is for sudo user only because we don't want to give access to Ram Sham. You have Git access. Enjoy, download anything, right? Commonly, we don't give access. So again, next. Yeah. Sudo. Go to the bash. আগে escape করে যায়, exit করে যায়. Escape mark. So we made maybe AWS is ASH is working or KSH is working. I try to make it as less vulnerable it can be, right? But yes, whenever the people is configuring it, they are obviously blocking bash. That is a very basic one. But here we are not accessing bash directly. We are using bash to spawn a shell. By how passing through Git, right? So next. Now AWK can be used as well. Previously you have seen. I don't need to give it. Go listen. Sudo. Okay, let's show it. No, Git is running. Git is running on root access. Man is not running on root access. So if you are showing Git help, then Git is opening its help page. Then only you can give. But if you are running man, it is a user access only. That user is. You can do it. Yeah. Yes. If that program is running with root. Sudo man ls. ls. Now you can do exclamation sign. Exclamation sign. /bin/bash. Again, it is root. So if it is opening using root user, then yes. Very exit. So it is the only the imagination is stopping you. So it is only the imagination stopping you, not the commands, not the quantum computing, encryption, and whatever the things you are talking about, right? As I told, demonstrated when you asked you the question, which logs to bake first? When I am focusing you toward the log, you are thinking about breaking the log. But hacker doesn't think that way. They are maybe ADHD or something else, I don't know. But they think in different way. That is why a 12-year kid can destroy Sony backend network. Else cannot, right? They don't know technology like you guys. So go to next. Yeah, same thing, root. No need. Next slide. There are many other ways as well. Now go for the best thing you have ever heard. Always go for secure, what is called SetUID. Whenever you are executing chmod plus X, don't go for 777, don't go for 677 and something like that, right? You never asked why. We followed it commonly, the Linux administrator, as a routine. Have you ever tried that if you are giving misconfiguration or not permitted chmod, what is actually happening? How hacker can exploit it? Because commonly when you are doing our regular job, we are using SOPs. Nobody is questioning it. There are procedure written and next, done. My task is done. But if you are not feeling from inside why you have done that, what I can be doing to bypass it, that is the question you should ask to make your infrastructure more secure, right? So we are testing it. Go to the. Now say a hacker had the access of root shell in any way. Now you want to keep their backdoor in minimalistic way. They have a local user account, but root account, he don't want to use those commands anymore. He need his own access. What is the easiest way? So I am just copying bash as tmp root bash. Do it. Done. Now I am chmoding it with a system bit. রুটের করতে হবে তুই রুট শেলটা খোল একবার যাবো অন্য কোনো রুটে ঢুকে যায় না আবার কি দরকার বিং CHO. हाँ वही तो बोल रहा हूँ फालतू को पासवर्ड क्यों देना
Like a true hacker would do, right?
yes he is from Linux administration that's the problem he always follow the rules now go to Bob Shell yeah oh so I just added ch mode no backdoor binaries no some mumbo jumbo tools and anything. I just copied the bash binary to TMP and set ch mode. Now go to Bob Shell. Huh? But so these RWS, S is what you are looking at. Now let us execute it as Bob user. Again, I'm a root shell. I am using P only because of bash doesn't keep the set GID setting by default. So if I am passing P, it carries the setting with it. So I am dropping into the root shell. Even if the UID minus P, it is, go to the presentation. Not copies, it is executed with the permission. No, it is set cap. If you are using dash, you don't need minus P as well. There is something called dash as well. So that is already the priority. It is not taking the, the bits with it. If you are directly executing bash, it may not take that set UID permission. It will only execute the program as his own user ID.
Effective user continues to be the
Yes.
Otherwise, it will drop.
Yes. If the command is dash, another shell, which is by default installed, that doesn't need this complication. You can do same with find as well. Exit করে ওটাকে execute করতে হবে না you can do same thing with these as well find as well you can copy root find and using find you are dropping in executing a command copy নেই root find copy করা নেই yeah so you don't need to do it you are just what I am doing I'm using the find command I'm copying to the tmp folder and when using that command I'm executing bin.sh and quite
You have to copy find to do.
no I am not demonstrating it it's already the same thing right yeah yes না না তুই ফাইনটা কপি করতে হতো ছেড়ে দে ওটা ছেড়ে দে উড়িয়ে দিয়ে দুটো ফাইলকে উড়িয়ে টিম রুট দিয়ে যা কারণ পরে তো একই নাম ইউজ করা আছে হবে না বুঝলে পরেরটা হবে না go to the slide again no root bash enter ma delete করে দে হ্যাঁ বাস হয়ে গেছে ছেড়ে দে Now let's go to the slide again. Now there is a next slide. Next. Now the back. There is another thing in Linux. It's called cap. Set cap security. What it does, say like your command having functions like A, B, C, D, but cap SUID. What gives you specific access to that command. Very rarely people use that, at least in our scenario, but it exists. That can be exploited as well, but we are not going for a demonstration if you don't want it, so we can go forward. Because it will be the same thing, just using that capability. There is a dedicated website called GTFO. These techniques what you are showing is called LOLVAS. In Windows, it is LOLVAS. In Linux, it is LOL means living off the land. Means I am using the existing command and executing it in my way. In Windows, it is called LOLVAS. Linux is called GTFO. Right? There is a dedicated website for it. Which command can be used for what? And it is always expanding. I'll show the website later on. Let's go to the next slide. Slide. So let's move on to the next area. Now, very common thing, cron tab. People make a lot of mistake in cron tab. They execute their own script, but forgot make the script read writable for all. Very common. Another mistake I want to point out today, and this is not new exploit. This is a very old exploit which is still working on all Unix systems. It is called tar injection, tar wildcard injection. Now let us go through the demonstration, how and what it is. This one is very old attack. Again, like maybe 10, 20 years or more than that. Bobby. So this is the cron tab we have in our system. Those are the first things are default. One thing is suspicious, right? For 1 minute is running as a root user this script. Can you see it? It is running a script from /etc/cron daily, executing per 1 minute. You know, every single 1 minute is executing. There is no other misconfiguration over there. Only one cron tab entry. Okay, let's inspect. Let inspect. So what is the permission of this script? Let's see if it is writable. No, it is not. Only executing permission is there for the user. Executable. You cannot edit the script to view, to manipulate the functions as a root. Let's chat করে দেবে ভেতরে কি লেখা আছে So let's see what is there in the script. Control L মেরে কর উপরে উঠে যাবে So if you are seeing it, it is running a shell script which is properly chmoded, so it cannot be manipulated to add something else. So it is browsing home directory, then making a tar of that home directory and keeping it inside /etc/backup and naming it as home-username.tgz. So inside home directory, there are multiple users, right? Bob user is also having his PWD correct? Is also having a home over there inside the home directory. So it is making a backup in /etc/backups folder per 1 minute. So this is what is happening. So go to etc backup. So look, it is generating these files in root permission. Others only can read. Only root can read and write. So this is configuration wise secure. Many people have done mistakes that they are keeping ch mode 666 777 to that executable file, and hackers can write on that executable file as it is running on root. It can be manipulated to get root access in other way. But here is not the case. But here people are using tar command. Let me give you a command first as a demonstration. Don't execute it, just open it. Presentation Takul. So it is what we are going to do is called tar wildcard attack. We are going to execute and add the argument in tar. Means whenever you are tarring something, what you are doing, tar jcvf, then file name, then folder name, right? What that is why how we are making the tar. So if I am doing tar like this, tar minus cf, whatever the folders are there, minus checkpoint 1 and minus checkpoint action, then I can pass something to execute once tar is done. So I am executing bin sh. You can use tar to exploit and drop on a shell, maybe root shell, maybe user shell, I don't know. But it is executing bin.sh. This funda we know that is by default tar's behavior. But in our case, tar is executed from a shell script, and it is, as a hacker, I don't have access to root to manipulate the the checkpoints, these strings. So now how to exploit it? Let's go ahead. What we are going to do, we are going to create a file with those arguments names. We are creating a file. It's called shell.sh. Whenever it is execute, it will drop me to a shell. And chmoding it to +x. Done. Now the magic part is coming in. Go to it. Next comment. Before pressing enter, stop. Not দুটো command আছে. So whenever I am pasting this command, this action will start, right? I cannot stop it. What is happening? Whenever I am giving these two commands, দুটো command copy কর, action দেয়। দুটো command action copy কর। উল্টো করেছিস তুই। Whenever I am creating this command, actually what I am doing, I am echoing blank to a file name, this argument as a file name. As Linux can create any file name you want with whatever the ASCII character, with that argument of tar, I am creating two files, a file name. So one is checkpoint, copy paste korbe. Now, if you are going to my window, NC, I already received a connection from the server. Now, how it is happening? Per 1 minute, it is making a backup. Go to Bob directory and ls, tweet ls. So look, in Bob directory, two files are created. Minus checkpoint equals to 1. Minus checkpoint action exec, that same command, right? Those are file names over here. Now it is called kind of contextual bypassing. All hacking like SQL injection, XSS injection, all hacking goes in this way only. Contextual bypassing. So what it was told, if you are what in this file, what is happening? Tar minus ZCBF. Now we are defining the folder, and what we are doing, we are backing up this folder names. So when tar is running, as the star is there, in that star portion, it is giving the file name. but file name becoming an argument. So whenever it is running the tar command, it is actually executing rather than zipping it. Because it thinks
All the files it will take, and at the end of it, it will add this.
yes.
Minus.
Yes.
Okay.
Because it will think it is a argument rather than a file name. So it is what is that doing? We are again opening an NC backward connection to our Windows system, and we got connected. I did.
But a quick question here. Tar would have a maximum argument length limit or something.
Maybe, but it is not working over there.
Yeah, no, I'm just thinking if you have too many files, then it might hit that.
No, I think no, because I have seen tame folder. I have done tar as well, right? Long file length with the cookies and all, but it was tar as well. I don't know what is the limit, but not very small. Like it is doable. Really, exit. So it dropped me in root shell. Remember, because the script was running from root, tar was running from root. So I got the root without even exploiting it. ডিলিট করে দিলে বারবার হতেই থাকবে আনে মানে আরেক পেনে দেনা দুটো ফাইল নেম ডিলিট করে দে মাইনাস চেক পয়েন্ট I am deleting those file name only because of else it will keep running and it will always getting connected to my system. Minus star mere dena. Nebe ki nebe na. Look, it is also not taking it as
//
// का কোরআন জল খাই হ্যাঁ সব ডিলিট করে দিই ছেড়ে দে বাবা নেক্সট যা প্রেজেন্টেশনে যা So the last one I am going to discuss is Docker. We are all Docker users, all here over here. So let's talk about Docker privilege escalation without going for any complexity, 0 days code, creating some bugs and exploiting it, blah, blah, blah. Don't think all about it. Let's talk about Docker user group permission. So here, Peter is a user which is having added to, it is already added to, next layer. নিচে ছেলে চলে যা পিটারে চলে যা This Peter user, not Bob user, ID. So if you can see it, it is a common user, Peter. Peter group is Peter as well. Only he is a member of Docker user group. Commonly what we do, if we want to give access to some user of the Docker, we add them to Docker group. Don't do it, it's dangerous. Just by executing one line command and giving internet access, you will be get owned in second. Let's demonstrate it. Then I will discuss what is happening. There is no mumbo jumbo, it is only having access to Docker user group. এবার ওখানে যা ওই সেলে যা ওখানে লেখ cat slash
Move to S is what?
huh?
So by doing that, we are able to just run the shell as a Docker shell of the row.
Local, I had mounted the local drive as a host drive. Now, if I'm doing cat shadow, I actually can view main password file of the actual system. So what I have done, there is a something called one Docker called root please. It is already there in Docker. There are many other as well. You can create of your own. What it is doing, it is mounting your root file system to Docker root file system. Nothing else. So actually, your Docker is becoming your host OS. It is having the same access as it is running Docker service is running via root. It is having the same access. That is why nowadays people call use Podman or something else, not Docker in direct sense, right? So if you are using a single user to Docker group, he can take over your root access. He can add anything inside your file system and whatnot. So a single command and 1 minute you have taken. So yes, this is another demo. Go forward. It is already do. Record. Call. So the details are written over there on these files. Next. These are the URL you can check. Few of them, there are many. What GTFO beans I was talking about, these GTFO beans already there. Open that site. Internet is there. Click. So these GTFO bean website. So you can non-interactive by itself, keep up there. So these commands can be used. Now click on that command. Any command. It will give you all the details by which command executing what. You can get access of what. So now it is your imagination blocking you to get the root access, nothing else. Now presentation चलिए. So there are many others. I will share that the presentation with you. You can get it. What we have done is CLI privilege escalation using existing commands. So if questions we have taken, if you have any more questions, you can talk. Yeah, please. Yes, but if you are creating a rule, the scanner will think maybe that is right. What you
So
like sudo.
Yeah, like what if I what if these scanners detect the permissions which are not
Yes,
allowing
yes.
you to do this?
Yes.
So do they do it is the question.
The problem is, if you are looking at a company, say like Razorpay, right? Razorpay having around 5,000 employees, I don't know.
Right.
So there are many developers as is Razorpay.
Right.
So as a company, if these kind of warnings are coming in, this is just warning. It means SIEM desk if you are talking about, or these are just information warning, not high alerts commonly.
They don't
check it.
They don't
Because they only 30, 40 team members are there. Who will go and check the warnings? There are random others.
As a part of hardening Linux, I don't know many people do it or not. I don't know. They just take the default OS as is and run it. As far as I know, that's what we used to. I mean, olden days, I don't know how many of them do today. There's a process of Linux hardening, which includes kernel hardening, and hardening means a scanner which is mostly written by the folks who are there in that, which scans for all the vulnerables which you just spoke about.
You were in Yahoo, right?
I was in Yahoo, yeah.
That is why you talk about kernel. Nobody hardened kernel anymore. Nobody touch kernel nowadays.
Linux, yes. Yahoo, we used to do that.
Yeah.
And I remember using a separate hardened kernel for that, or even before that, like, of course.
GRSec, right, I think.
I was with YST with Devanshu.
Okay.
So he knows that. So these vulnerability scanners, I know you're saying the severity is lowered is what you're saying. If they find, like, for example, like how we have a Kubernetes, like it says, okay, you have a configuration which can be used for vulnerable, used for exploiting it. So like this, we have it for your Linux also, like scanners. We have seen some of them detecting the high level ones.
Yeah.
But this is very useful.
Yeah.
Not everything is covered there because some are run at the runtime. They don't stay in the system.
Exactly.
But not everybody, but some of them have these precautionary measures which they take to avoid this kind of exploits.
Yes.
So I'm just trying to ask this. Are you aware of any scanners like that which can?
No, there's a company, right? Computer Security has CIS, right?
CIA is one.
The problem with CIS, you cannot adopt one.
No, not.
I'm a
nobody
member of
reads the
CIS
entire
for
thing,
long,
yeah.
right?
Understood.
If you are going for level 3, level 4, your system will get blocked, right?
Right.
So if you are talking about kernel patch, what it is doing, it is segregating the user memory with the kernel memory. So kernel, when it is executed inside the kernel memory, anything from the user space will not go to the virtual space of the kernel.
True,
memory,
true,
right?
true.
The problem is there, in present situation, by default kernels are doing it. The issue is I'm not using kernel at all.
No, I got that. I got the. So there are two parts. One is the kernel part, which is the actual Linux, and remaining is the GNU part. I'm talking about. I think you spoke about GNU here mostly.
Yeah.
So these permissions which are there on the systems, which you have file system permissions, or set UID issues which we spoke about, exploits, how you're exploiting it. So they have to. You have to set some attributes, or
like for what thing I have done in my case, what I have done for Ericsson small scale. There's a small Linux group for our security team only.
True, got it.
Yeah. So what we have created a one LLM with all pseudo configuration and whatever
to scan it.
Yeah. So you just keep post pseudo configuration, and it will suggest you what can be done.
So it's like more of like you don't have a global tool for it yet.
No.
Okay, got it. I got it. Answer.
There is global. There are maybe I don't know.
Sorry. Yeah, the thing is, what I was asking, specifically to the exploits, these are at very low level. A lot of people, they
low hanging fruit, yes.
Yeah, they're very low level. People just take, now today AWS, Azure, whatever image they get, we simply use it. They'll not know the internals unless you. Yeah. So. Oh, mic, take it.
So in the past, we have done that CIS benchmarking on our Linux systems. So there is a repository we found out. Basically, it has the number of asset scripts, shell scripts, which will. Yeah, it will tell us which has passed the CIS benchmark, which has not passed the CIS. Yeah, it has to be run. And CIS benchmark company also has a tool which does that for you. Yes. And it also has a tool to fix it also.
So we do it.
Yeah.
I mean, most of the people don't do it.
Yeah.
For others to, they find it to find.
Yeah. But CIS benchmark has their own tool also to do this. CIS benchmark. Yeah, it's only for members only. So we hardened our system as per the CIS benchmark.
That's the problem. Buddy, my point is that is the problem. We are following some standard.
Right.
Because if you are looking at any GRC compliance, they are giving you these and that to be done. And how it is decided by few senior architect, designer, planner, and they are giving you these are the parameters you should do. But until and unless you are confident that what is given by them, it is tested by us. Zero trust mechanism, right? I don't trust anybody. I will check it myself, then I will get confirmed. Because CIS is getting deployed, updated per month.
Yes.
Are you going to check per month? No. Right? And it is not one time chakkar that once it is run, it is secure. Nothing is there, right? So that is the problem. Until and unless you don't understand, if I am not doing it, this is going to happen. Then only you are clear. Else not. There is nothing called security, that level. Every day, think hundreds, like previously it was told, one of the FBI director told, there are two types of company in the world. One is who is getting hacked, already hacked, and who will be. These are two types of companies. Nowadays, someone from X-Force, IBM X-Force told, there are no companies there which is not yet hacked. Only the game is how fast you can detect. But how you can detect, not by watching some tool, it is not possible. Only by your intuition, okay, it can be done. Have I checked it in that way? No. So let's check it. Yes.
What are your thoughts on we want to level to IT security or app armor when you use that?
Because app armor, when you're doing, your application is failing. Most of the applications are failing until unless it's heavily configured.
Will this exploits work then? If I use SC Linux, for example?
Maybe Git status backdoor will not work because that relies on multiple layers, right? But Bash is basic. AWK is basic.
They have those.
Yeah.
Okay. So that restrictions
is
are
that
not
more
there.
like-
You're saying the Bash will have that permissions in SE Linux also given full.
Yes.
Okay, got it. Okay.
Until and unless you are not using
No,
cap
right?
ECUID.
Nothing like that, right? Okay.
Huh?
It will not work. It will not work. Is okay.
Maybe I'm not sure. Like I haven't tasted. The problem is AC Linux after deploying it, your application also will not work. That's the main problem, right? Sorry.
I mean, they're written that way, which is a bad thing.
I tested in my experience. GRSec is the most secure, most plugin with GRSec. There is an open source developer which used to develop GRSec very rapidly for cPanel host back in our days, right? Nowadays, he is doing, I think, paid version, but that is one of the best patch for Linux is available.
GR, I remember.
Or
those.
go for FreeBSD.
Okay. BSD, free BSD, yeah. I'm a fan of BSD. Thanks.
Sure. Last slide I have. Yeah. CIS computer security. What is that? It's an authority kind of. They give you a framework. So you want to secure a system, do it in this way. So if you have Linux this way, Windows this way, and all this. Next slide. So yeah, I need one last thing for 2 minutes. I need your yeah, please. Time is almost over. Yes.
Thanks for wonderful demonstration. My question is around like whatever you showed, is it running in the user space or like a kernel space?
No, user space only. Whatever user space.
Okay.
I never touched anything kernel related exploit yet. There are possibilities to exploiting it, like loading library, that ISO file.
Yeah.
Inside the kernel when Linux will reboot.
Shared libraries.
Yeah. It can be done as well, but those are technically high level attacks. Don't need it to. Right? Or bugging SSH binary itself for backdoors.
Yeah, because once you are starting leveraging the SE Linux, whatever Linux security hardening you are doing, you are running it in the user space. The moment you start touching the system calls and then context switching happens, your game changes. Whatever security standard benchmarks you are provisioning, you just think outside of that box.
Yes.
And you started.
So if you want to think security, think like a hacker.
Yeah.
Or else don't even touch that door.
Because I've tried more system calls, your vector attack increases.
Yeah, but the problem is common hacks don't goes in that way.
Yeah.
Common hacks goes in this way.
Yeah. More of like touching user group level permissions.
That is
right. Okay. Thanks.
Thank you. Yeah. So I'm need 1 minute of you. So we are creating a platform, startup or whatever you can say. It is a email platform, but in a different way. It's called apnamail.in, right? So still now, email structure has not been changed. You are using emails since your childhood, since your birth, like your parents also used in same way, which was given by Sabir Bhatia in Hotmail. A web-based interface, emails coming in, emails going out, outbox, inbox, and all, right? Nothing got changed yet. This is the first time we are going to introduce a desi mail in desi way. If you are looking at Indian people, only the urban IT experts are always into their emails, right? They are always checking their emails. But what about our parents? What about the Kirana shop in our locality? Everybody need an email address nowadays for your Aadhaar card, for your payment transaction details. Fintech also is mandate to the fintech. They need to communicate with the customer with the email and give them the. But how many people checks email? If you go to your Gmail, you will find 200 emails unread. Your parents or your wife or your spouse who is not in IT, 5,000 emails unread, right? You need to clear the inbox to get new email. That is the situation. People don't read email. But what about WhatsApp? What about your Messenger, Instagram? You always read it. Any message is there too? Okay, aha. So we created a platform. It's called apnamail.in. This is the first time in the world, your emails will be delivered in your WhatsApp. There is no inbox to secure. You don't have a password. You are just creating the email using your WhatsApp. Your emails is directly coming to your WhatsApp and you are operating through WhatsApp only. There is no such inbox which you need to maintain. In a sense, it is Aadhaar verified because your phone number is Aadhaar verified. Every phone number is having only one email address. In a sense, you don't need a password because your WhatsApp is already secure. Our email don't need anything. It is directly delivered to your WhatsApp inbox. To create an account, you go to apnamail.in or you can scan this code. We need some beta tester to check the load, how much we can handle the present situation and all. Running fine. All the basic function will be. We made it much more easier for even our parents, for the Kirana shop owner. And later on, we will try to translate it into multiple Indian language as well. So you can choose, you can get your mails in your language. So by thinking about, people from village areas, far, inside areas, everybody can have their email if they have a mobile and WhatsApp. That is all. Yes, thank you.
Thanks to Krishnendu Square for this lightning talk, because I'm pretty much sure we would have loved to do a hands-on session out of it. Okay, but these days doing hands-on session is a lot more logistic involved, so we are unable to do it. I think people will go back and see the recordings, because I'm pretty much sure those who have not taken notes, it's not easy. We'll share the decks in Discord, so we'll please join our Discord channels and all. Tonight, I will once again drop an email giving our Discord channel server link and all, so that all of you who registered for the event can join. Okay, super. Last but not the least, I will invite Orkodip for his talk on how to plan for a recovery mechanism when every cloud infrastructure is down. Okay, Orkodip, you on stage.
Guys, can you please come this side? That will be easy.
The photo looks a little disparate. So if you close, then the photo looks nice. Yeah. Right.
Okay, fine. Hello.
I'm going to keep the mic closer to the.
I hope am I audible on the last bench? Okay, fine. That's okay.
Use this. This is louder, better.
Okay, hi, good afternoon, everyone. And today we are going to discuss about the building some parallel service when your major main infrastructure fails. And we have experienced something in recent past. You guys can all remember about the AWS outage, Azure outage, and also the Cloudflare outage. I hope people in enterprise can relate that how the P1 call started, how long it continued. So let's talk, and just to give a disclaimer, whatever we're going to discuss today is kind of public knowledge. Nothing confidential from the company perspective is being shared. Talking further, so first part, let's talk about where the transaction happens. Let's first take an example of the e-commerce site. Any idea per minute how many transactions take place? Let's make it interactive. So people in Meesho or e-commerce company can vouch how much per minute transaction, any idea on an average or maximum level? Any guess? No price, sorry. 100K? Yes, absolutely. Super. So per day, on an average, balancing out, it is 1.6 million per day, and per minute on a peak hours, it is 100K, correct. Let's take an example of the UPI. So there are PhonePe, Google Pay, and let's take another guess that how much is per minute transaction volume per minute, and then we'll come to per day. Any guess again? Louder, please. 1 million. I think it is closer 5 lakhs. 5 lakhs, 500,000. And in India, we cater approx 700 million per day. Okay, I have to be that side. Okay. So per day, this million. And now comes another interface, which is the stock market trading platform. The volume is quite high, and user is allowed only to place 200 orders, and in one order, there may be 1 lakh volume. and generally 10 million active users. So a trading platform handles this much traffic. And on an average, 400 million shares is being traded per day. And you know that trading have a stipulated window of approx 6 hours. So we have a clear winner here, trading platform. So whenever the outage happened, it affected every platform. But why I choose the topic of the trading platform? Because here financial volume is quite high, and I will come back in a while. So let's talk about that how trading platform works. So say, for example, let me take an example of the Zerodha. So on the left side, there is a user with his mobile app or desktop app. Through internet service provider, connect to the web access firewall, followed by AWS application, where there are multiple microservices, multiple backend technologies, everything is working on that block, and then order management service, and then through list line, it is connected to the stock market, NSE, BSE, MCX, whatever. So here is the common platform, and be sure that it is kind of a not that simple, and there are so many redundant paths in case of any high traffic or anything related. There is a mechanism that it will take the next possible route, and your journey will be seamless. So what are the disaster recovery method in case of normal event? We don't know that when and where it will happen. So we always have to create a disaster recovery method. So first is that we have to have the auto scaling. So whenever load is high, whether it is infra load or order volume is getting high. Second thing is that replication. We can move the database to primary to secondary or probably the tertiary. Followed by we have the load balancer, we have the CDN by which we generally cater. But out of all these, first one is the AWS, so which is cloud, and not pointing to any cloud provider, it can be any cloud provider, and that may go wrong. So let's talk about the trading part. So generally, as per the definition, you purchase something on the day and sell on the day, same day itself, by which with the arbitrage or with the price difference, you try to earn money and you try to maximize your potential earnings. And next, moving forward. So come on. Okay, fine. So let's take a scenario that if the outage happens, you guys, we all have faced that. It can be in private data center or the public cloud outage. Then what happens? Suddenly we got to know that half of the internet went down. We can see the down detector spikes up. So let's see. So we have experienced something like that on November last year. It was DynamoDB on the Azure US East. It had failed. We could see from the down detector that so many applications, this is one part of the screenshot, what all application has failed. And followed by few days later, Cloudflare also failed. More on this are available over their blog. You can have a detailed read. But this is the outage reported by the service provider and the consequences we all experienced. Not going to talk right now. Now, what is the consequences? This outage happened. What happens to the user? Let's take a guess. Say, for example, you want to find you are kind of doing trading. You put a volume that, example, 100 rupees share, you have put a 1000 share purchase order, and you need to square off. And suddenly you got to know, or probably in the market, there is a news, there is an outage. What may happen to you at least? Any thoughts? Yeah. Panic, correct, absolutely. So anything? Absolutely. You want to get out of it. And also there is a panic in the market. So price might get affected. Very good points. Any other thing? And let's talk. If you don't square off, what will happen? Absolutely. That's the point. Already there is a negative news. And if you cannot then access, let me take my example. On that day it happened. I simply got logged out. Every time I log in, automatically logged out, and I cannot do anything. Got so simple as that. You correctly pointed out that investor will be in panic and they will try their desperate effort to square it off, but they cannot. So here we have read about one of the article, which I'm going to present in a while. And that's how we will solve this problem. So about the rescue mission. So whatever initially I have presented, it is about the cloud infrastructure using the Cloudflare web access firewall, multiple microservices, multiple components connected together and making your order placement fulfilled. But if that system fails and you have open order, as my colleague friend correctly pointed out, that we have to square it off. How could we square it off? So we have to have some alternate system which is not dependent on the the public cloud infrastructure or the server which is affected. How could we do that? So let's take again Zerodha example. That here we find a beautiful example that first user will again go through ISP. ISP is not affected at all. They have solution WhatsApp. Simple as that. Everybody have WhatsApp in their phone, and that uses the Meta infrastructure, followed by that is hosted some part on the Azure cloud, and then it is again going to the order management system and followed by NSABSE website. Over there, if you follow the last line, the limited functionality that you can only see your holding and you can only square off the positions, whatever you have placed. You are not eligible to add money or withdraw money because it is a emergency break the glass scenario where you have to just square off in order to reduce your loss or probably book your profit. So that's one of the architecture. And here is a beautiful read. The deck will be shared. So here if you follow the last one, that introducing kite backup. So why the question is that why we cannot create an alternate backup system and creating a WhatsApp-based platform? So the easy answer is that already there is an existing backup strategy with the AWS. But when the Cloudflare like outage happens, you simply every service is getting impacted. Then you have to think out of the box and think about that how quickly you can get access to your system so that you can square off your position. So that's why the WhatsApp-based architecture, which is easy to handle, and we can quickly log in with and authenticate ourselves through the WhatsApp flow and then solve that open positions. Moving ahead. So what probably up to this, what thing probably comes to your mind that what we can do to build a robust system? Anything? Sorry? Alternate channel. Okay, fine. And anything, what does that calls? BCP, yes, business continuity. Absolutely, both of you are correct. So I can call it as a resiliency. So we should have some solution so that it does not impact the customer. Few learnings, that's totally up to you, and you can add points also. So all systems are bound to fail. Jaha system taha vinasham. Anything can fail. And it's about the customer interest because customer pays us the money by which we run our business. It's not about Razorpay or anyone. But if the customers are getting impacted, then it's a huge point. So if we can help them into the urgent time or probably BCP time, then it matters most and it makes the customer delight. And finally, this is about me and thank you LSP and the Razorpay team for hosting. That PPT is already uploaded over the portal, and here is my LinkedIn page so that we can connect and continue the discussion forward. I would be taking a pause to have any questions.
So you talked about that WhatsApp kind of mechanism. So is this an idea or is it somewhere implemented in a POC or something?
It is right now in production with Zerodha. I'm not from Zerodha, but I find this as a interesting read. And if you have, not promoting, but if you have a Zerodha account, you can just try that. They will authenticate with your PAN number and your Zerodha trading ID based on the OTP that will be authenticated. And that's kind of a break the glass scenario. And as per their claim, if you read the blog, because they are not using the complex architecture of the multiple microservice, multiple Elasticsearch, they're only giving you options to square off your position. As one of you told that it is about to safeguard yourself when there is an outage.
Yeah, thanks.
Because if the Zerodha platform goes down, you can't square off your positions. And I don't want to name any specific broker, but most of the broker has a bad history of going down multiple times. Again, another layer which is getting added is the cloud service or any service provider like Cloudflare goes down, again they go down, right? So you need, and many investor has lost quite a bit of money. So that is where each broker has to provide alternative channels, at least the investor can square off their positions.
Absolutely right point. I had documented 2 links that during the outage, not only in India, all across the world. And you can probably see yeah, here you go. So this is Robinhood, US second top broker, and that's customer lost a huge amount of money. And you have simply no explanation, no insurance for this kind of scenario. So that's why the alternate strategies provided by the one of the Indian company. Find it at a good rate. Over to you. Any questions? Yes, please.
If DynamoDB has gone down, right? In that case, your DB is not available. So any other, okay. In this case, the DynamoDB has gone down, right? In that case, your DB itself is not available. So in that case, how the other channels will help?
Valid point, of course. And let's come back to the answer. Yeah. So if you see that prior to the main architecture diagram, we had cloud service provider as AWS, for example. But here we have a, as you know, that we always do a data replication. So here we are having the replica of whatever order you have placed. So when you place the order, that order, I mean the transaction ID and every details is getting stored, and that is also getting replicated over the other database. It's not the DynamoDB, but rather in a Meta platform or the Azure platform. So where it's your previous order details of the day are kept. So we can square off from this position. You want to add?
Adding to that. Adding to what he's saying is Zerodha uses a lot of Redis cache. So they don't use database for the trading and everything, whatever the order you are pushing and pulling. So they put it on Redis, and from Redis, they have another job where they put it onto their databases. Mostly what I know is they use, don't use the DynamoDB itself. They use
memory cache.
No, not Redis. They use our regular RDBMSs. Postgre they use it. Yep.
Any questions?
So I think only one region goes down often, right? Only one region. If we are having multi-region deployment, then I think mostly we should be able to solve the problem instead of going to another cloud.
You are absolutely.
DynamoDB in East went down, everything went down because that was a critical section.
No, you are absolutely valid, and that's why in the main architecture we have mentioned that it is over the multiple availability zone. So by default, it should not impact.
Right.
But this is one of a kind. I mean, one of a decade. What the outage happened. So
That DynamoDB in US is sort of the centerpiece of.
if you remember the memes, what circulated.
Services which are global. Okay. So Virginia goes down means some part of AWS will be estimated. So there are some services which is not beyond Virginia. It has to root in Virginia, otherwise it will work. So I don't work that for example. Okay, if Virginia goes down, globally it will be
Goes down. That is the challenge.
if DNS goes down, I mean route 53 goes down, Virginia goes down, this route 50 has to go down. It is something of that. It is Washington control. Think
Right. Yeah, but the way they claim, right, multi-AG or
No, I can answer you this way that.
Their source of truth in many services, many core services, CloudFront included, is Virginia centric.
Let me add one point on record that before November 18, we never knew that US Virginia hold that much importance.
Correct.
Nobody knew that US would that.
So we always believe that cloud is multiple availability zone, etc. But they expose their vulnerability.
For AWS is this, well, more than 6 months ago. So nothing being official. So the way it works is everything will be tested in Virginia first. Every new service, these has to be deployed and tested in Virginia. If it is not in Virginia, it is nowhere in any global region. Okay. And there are core services which core is Virginia. I have seen outages and services where AWS has a very good policy of doing region dependency and all those stuff. I've seen architects, principal, something of that sort, who knows the deployment more or less in their mind, like the fingers from their hand. Used to scold on service architects saying that you failed because you have not followed these 3 steps to build your service. So within AWS also, at Yahoo, we had a very stringent architect board approval. If ARP has not happened, your service is not going to go anywhere. Okay, we and Srivas used to defend our services. If once in 6 months, if you fail to BCP 2 times, your service will be deprecated below the 10 and will not be called a revenue service. Okay, this used to be the standard. And if you are failed, then you have to prove it that these are my problems and I am fixing it, I'll fix it and I will establish it. Okay, we both have done it for one of the top class services at Yahoo, which is called Answers. Okay, we're to show it. Now, what happens is AWS is really big. Okay, 240 plus services. Who knows which service does how much of revenue? Nobody knows. Okay, probably somebody knows, but at least people like us who are facilitated with service doesn't. So it happens is almost all the time people will use shortcuts to publish something. Here, a lot of bureaucracy to do some big stuff, and those are the culprits in and out it.
Right.
Okay, all the time.
Right. I think nowadays, when from ARB to service team, people has moved around, all responsibility come to the service team who is owning it, even from architecture to deployment and servicing that. Earlier, ARB was centralized. So in enterprises, they showcase the bottleneck because there are a lot of requests pending over there for a long time to get approved. That's where they build a services team. Okay, services will own end-to-end architecture, design, delivery, service, and everything.
The problem is people move, right?
Yeah.
People having the knowledge move on, and that's where the tribal knowledge misses.
Right.
Okay. The inside AWS there is a DHCP service which is used by them. You see the complexity of the DHCP, right? Every of your network has its own private IP space. And this private IP space is nearly same, it is duplicated across all edges for all customers. You are a customer, you also have come into 168.1. He is a customer, he also has come into 168.1. Okay, so that the DHCP service itself inside AWS is very complex. Okay, if they made a simple blockchain which increases the packet size by 16 bytes, the service will crash. Okay, and one particular scenario, I think early 2024 or late 2023, Big Mac went down in a month twice. People are trying a deployment, something broke, the robot is complex. Okay. Then they thought, okay, this is the issue. So basically, microservices and multitude of teams, who is doing which change, and ultimately which change is affecting the mainstream is very difficult to trace in a distributed development scenario where things are dependent on. Okay,
Right.
That's where the complexity today, as of today. We are very happy because we have avoided the team politics by doing microservices. Okay, you deal with this. You don't have to bother about this. But then you are impacting it. Okay. If it is only the API layer, the broker, all agreements are fine. But there are things which is beyond API, which breaks stuff pretty often. And
Right.
major outages are because of related services going down.
Correct. I think nowadays it's a demand that parallel to cloud, we should be thinking of another system.
Yeah.
Right?
Microservices. Well, I mean, you must have read a lot of debate on only microservices. One part of AWS actually went against the standard norm of being microservices, and they became monolith, the prime video for it. There was a lot of writing around it. And there are fights among VPs and LPs. No, those fights are start from 1991, no? that is you with YBLR. No, not me. The Linus Torvalds and Tannenbaum. You remember that there was a flame war that Tannenbaum told him that had you been in my class, I would have failed you for writing a monolithic kernel in this age of micro kernels. You would have been in my class, you would have failed. Yeah.
Okay, guys, thank you for being a wonderful audience. I wish you have a good day, rest of the day ahead. Thank you.
So thanks for everyone, to every one of you. We'll do a group photo. Please come here. There'll be snacks served there. So I'm not saying anybody. Oh, you want a demo? We will do that. No, I know which demo you were talking about. So what we'll do is we'll stop the recording. Okay, just stop the recording now. Okay, and I will connect my thing to your screen. It will do without Zoom and all. So we'll do a demo of it weekly. Okay, and then we'll do a group photo and there'll be snacks up there and then we leave. Okay, great.